So in this tutorial, we will be making a pretty cool game. The game's name is Asteroids. So here's an example. It's a little big. Let me just turn down the sound so everyone can hear me. So here we basically have a new game, settings, and a quit option. And we can say new game. You get started a game. It has fading text. It has a working high score. It has a score, and it has lives. You can shoot things, and you can go to the next level. And then there will be more difficult times ahead. You can crash, and then you'll lose a life. And you can shoot things. Now this may look incredibly simple, but it is pretty complex, with a lot of things working inside of it. Let me just go out of invincibility mode, and there we go. Then when it's game over, you have a fading game over screen, and if you have a new high score, it will save that high score. And then boom, here you go. So that is what we will be working on in this tutorial. For future reference, if you ever do fall behind, you can go to GitHub, and the link will also be in the description. But you can go to GitHub, Webnetsu, YouTube project, and then in here, you can go to Lua and then the Love2D folder. Inside of the Love2D folder, you will have an Asteroid game folder. And in here, you'll have all of the tutorials, and you'll have some homework if you want to do it. Now, what do you need in order to start with this tutorial? Because some of you might be completely new. First, you need to know Lua. If we go Lua crash course and we search it on YouTube, then here at the top is my crash course, Steve's Teacher Full Lua Programming Crash Course. You will need to follow this course if you want to follow along. Of course, not all of the topics are necessary, but a lot of these topics are very handy to know about. And once you know this, it will be very smart of you to know a little bit about Love2D. So Love2D right here. And here we go. Now I recommend you know at least this one, and this one. And then I would also recommend you follow the previous tutorial, game dev tutorial, where we created the Save the Ball game. This tutorial covers some really basic items from Love2D. And if you follow the tutorial, then this tutorial that we're going to do now will be a lot easier to follow along. First, we need to create a folder for all our things. So I'm going to go to Documents, going to go to my trash, and then I'm going to create a new folder and call it Asteroids. I don't know how to spell asteroids, but I hope that's correct. Cool. Inside of this folder, and you don't necessarily have to do it in your trash folder, I just have a trash folder for tutorials. And inside of this folder right here, you can create a new file, and you can call it main.lua. Now once you have created a file, you can open up VS Code in here. I wonder, can I open up? I can't open up from here. Anyhow, I can go here to my terminal, but you will probably have an option to go here and just right click and say open in VS Code or whatever code editor you use. We can then just say code dot to open up VS Code here, and you should see something similar to this. We can close this folder here because we won't need it. Now take note, you do need Love2D installed and Lua, so if you don't have those two installed, I do have a tutorial at least on how to install Lua. Then here we have our main.lua. If you also use VS Code, you can get the Love2D extension right here. And you can also get the Lua extension right here. And you also do Lua debug if you want, but this is not necessary. It will probably auto download anyways. Anyhow, now that you have that, everything is ready to go. Let's just set up a basic project. I think for today we don't have to go all out. So just local love is equal to require love. This is an optional step. You don't have to do this, but it is optional. Then we can create a function We can call it love.load. And it's just a basic Love2D setup. And we can create two more functions for update. I almost said delete here, but this should be a draw. Now since we're starting off very basic, we're not going to do a lot. We only want to get everything up and running and maybe make sure everything works. If I were to run this by saying love dot, and you can also use the VS Code inbuilt terminal. We're going to terminal, new terminal, and then you will have the same thing as what I have. And you can just say love dot here as well. This is the same thing as what you just saw here. I just like this one more because it looks cooler. And then you'll see this. Pretty neat. We can then create a new file by clicking on this file icon here. And we can call it conf.lua. And here we can just say local love is equal to require love. Yet again, optional. You don't have to import love. Now you can say function love.conf to set up the config file. Pass in the app. And we can say app.window.width, and you can make it any width you want. But I am going to make it equal to 1280 or 1280. Then as for the height, app.window.height is equal to 720. For some of you, this might be too big. So just for reference, this is a 16:9 aspect ratio we're working with. As long as you work with the same ratio, you don't have to change too much. For example, a 1080p resolution, this is 720p, but 1080p would be 1920 in width and then 1080 in height. As an example, this would be bigger, of course. If you want to go smaller, it should probably be around 480p, but you can Google a 16:9 aspect ratio smaller than this. And of course, we want to set the title, app.window.title is equal to Asteroids. And then lastly, we want to say app.window.display equal to. Now, take note, not all of you will benefit from this display I'm using here. I have two monitors, the one on my left, which you cannot see, and then the one on my right, which you can see. However, I don't want the window to spawn on my left monitor, which is probably display 1. I want to do display on this monitor. So let's see, does everything work? And it does. It's big boy, and it has the Asteroids title, and it spawns on this monitor. So this one here is optional. These are also optional, but I recommend using them because why not? As for the window width and height, I recommend 16:9, smaller size if you want, but if you don't want to change the window height and width, then you don't have to. First thing I want to do is I want to hide my mouse. So when I'm here, the mouse should be gone. Now that's pretty simple. To do that, we can go here and say love.mouse.setVisible, and we can just go false. And this will set the mouse visibility to false. Now for future reference, we're not going to do that in this tutorial, but it will be smart to set our mouse X, mouse Y equal to 0 or whatever you want to here. So these will be two global variables containing the mouse X and Y positions. This is for a future reference, so you don't have to put it here now, but I do recommend you do, because then we don't have to worry about it. And then next up, here in the update, we also want to set the mouse X and Y. So I will actually just copy this, paste it here. And then here we can go love.mouse.getPosition. And this will return the X and the Y position of the mouse. Both of these are global scope. So if you wanted to, you can go _g dot, and that would be allowed. But for me, here I'm just going to say quick fix. And if you're in VS Code, you can choose one of these. And I'll just go here, disable diagnostics for lowercase in this file. Or even in this workspace could work, but I'll go file. And it will add this where it doesn't show that errors underneath these. And then last but not least, before we continue, I would like to set the show debugging equal to true. And this will basically say if we want to see debugging items. Right now we're not going to use it, but we will later. If we run this, you can see I can no longer see my mouse, but if I move outside of the screen, you see here, there's my mouse, but if I go in, it's gone. That is what we wanted. Cool. Now we can create the player. To do that, we can go here and create a new file called player.lua. I'm using a capital case P just because I believe objects, or at least other files, should use capital case P unless it's the main files or the core files going to be used by Lua, like the conf or the main. Cool. Now the player here will be an object. If you don't know how to work with objects in Lua, I do recommend you go watch my objects tutorial I have on this. Then you can go local love equals require and then love. And if you want to, you can copy this and you can put it in here. Take note that this diagnostics only works if you're in VS Code. If you're in a different IDE/code editor, then this may not work. Now we can create a function, call it player, and player will take in whether the player is busy being debugged, so debugging. So if we're debugging the player, then we want to see some extra information. And then at the end of the file, we can say return player. Nice. Now, some variables you might want to set at the start will be the ship size. These will be constant variables that will never be changed, so they are capital case. And we won't want to access them outside of this file, so we're not putting them inside of the return. We can make this equal to 30. You can change this, but this will basically determine the ship size. Because this would be from the left side of the ship to the right side of the ship. Then we can go local view angle is equal to math.rad 90. To get an example of what this does, because it transforms degrees into radians, because we want to use radians and not degrees. So to understand what we'll get here, we can go here and say Lua, and then say math.rad, and then 90. And that will give us 1.57 radians. So yeah, we're going to use radians, not degrees. Just keep that as note. So this would be 1.57 radians. And it's all to do with math stuff, so don't worry too much about it. Then here we can say debugging is equal to debugging or false. So if we do not pass in the debugging argument, then by default it will be false. That's what we are saying here. Now return is what we want to get back, what we want to be able to access within this whole thing here. So X will be the player X position, which is love.graphics.getWidth divided by 2. So we want the player to be positioned in the center of the screen once the game starts. So that's what we're doing here. We can then do the same for Y, and then Y instead of getWidth would be getHeight. So now the player will be positioned in the center of the screen. Then the radius of the player, and this will kind of be like the hitbox of the player. So the circle around the player, if that circle is hit, what happens? Anyhow, so the radius will be the ship size divided by 2, and then the angle will be equal to view angle. So the angle by default will be 90 degrees, meaning the player will be facing upwards. How do I know that? Because the player will be a triangle. If you've seen the demo of the game in the first tutorial, I showed you that the player itself will be a triangle that moves around. And if the angle of the triangle is 90, in terms of degrees and the radians 1.57, then it will point upwards. Cool. Then rotation will be equal to 0. So this is if the player has been rotated. Then thrusting will be equal to false. If the player is thrusting, that means we want to move because he's thrusting, is blasting out fire and stuff, which we won't code in this tutorial, but we will code later. And then the thrust itself will be equal to the x 0 and then the y 0. And I'll explain what all of this means later once we get to it. And then the speed 0. Cool. Now this currently won't do anything. So let's draw the player to the screen. So underneath this thrust, we can just create a function called draw. This will be a function that takes itself, and then here we go. Now local opacity is for future reference, but basically this will determine how visible the player is to the screen. So if the player is on the screen, can we see the player or not? Next up, we want to say love.graphics.set color, and then 1, 1, 1, and this means white. And we pass in the opacity, which is also 1, so it means it's completely visible. To draw the player, we can say love.graphics.polygon, and in here we can type in a lot of things that will draw the player. First of all, we want to draw the player as a line, not as something that's being filled in. So we can say line. So it's going to draw lines. Then we want at least 2 items to draw that line. So let's go self.x plus, and this will be a little bit of math, so bear with me. And we have 4 divided by 3, and note I'm using 2 brackets here. This is just for me to know, okay, I want to do the division first. The computer will know, let's do division first. But I want to know as well, let's do division first. Because when it comes to math operations and when to execute them, I am still a little bit junky on that. And we can say times self.radius. Take note that this is not inside of these brackets, inside of this bracket, but not inside of these brackets, because we want to execute this first. So 4 divided by 2, and I think that should be 3, and I'm going to explain this in a second. And then times the radius, and then once that has completed, we want to times that by math.cos self.angle. Now the 4 divided by 3 is mainly to find the center of the triangle. Next up, here we can say self.y, so we can copy that line, say self.y, keep everything the same, and in here, instead of saying cos, we say sin, because we want to go the other way. So let's create the player and hope for the best. So then here we can say local player, capital P, is equal to require player, and there should also be a capital P, because the file has a capital P. Then down here in the loading section, we can say player, lowercase p, is equal to capital case P player. If you don't understand what I'm doing, I recommend you to go watch my course on OOP in Lua. And then we can also pass in show debugging. So this will create us a little object of player that we can use and get data from. Now here we want to just see the player. So let me just draw player : draw. How can I use this? Because right here we export the draw function. It's inside of return, and then it should draw the player for us. Now if we were to run this, do we get? No, we don't. It needs at least 3 vertices to draw a polygon. Oof. Okay, so we'll have to draw the whole thing, unfortunately. But okay, not a problem. So since this is a lot of typing, I'm just going to paste this here, and then I'll walk you through it. So basically, here we have what we just coded, and in here we say self.x minus the radius, right? Times 2 divided by 3 times math cos self angle. So first we're going to times this because Bodmas, if you want to make sure of that, you can do that. Anyway, so we'll first times these and then we'll add this to it. And it's going to be the same all the way around for x and y. The only things that change is when sin and cos is being used. And yet again, I didn't quite understand this math. It was a 1 a.m. thing, so just excuse me if I don't quite know how to explain this. But you can play around with it if you want to understand it more. I don't really want to understand it more because it breaks my brain not understanding it, so I'm scared of understanding it. Anyways, if we try to run it now, aha, here we go. Does it quite look like the player? So let's see, what went wrong? Oh, you know what went wrong? Here we should minus it, my bad. Now, if we run this, we'll get a triangle. Cool. If you want to actually test it out for yourself and see how it looks, what you could do is you could run Lua and then open up a drawing application. Okay, now there is our X position and our Y. So X would be side to side, as you know, and Y would be up and down, as you also know. To remember this, you can remember Y has like this little finger goes like that, and you can add arrows here to specify up and down. That's how I remember which one is X and which is Y. Anyhow, so there's our center. Then what we can do is, let me just do that. So first we get our self.x, and let's say x itself is equal to, what is it? Okay, let's make it 20 or 200 because that would be more realistic. So 200 plus, and since we know this isn't going to execute yet, let's first go 4 divided by 3. 4 divided by 3. That's 1.333. So 1.33333 times, and in the radius, as we already know, is, let's see here, ship size, that's be 15 because ship size divided by 2. So the radius would be 15, so times 15. So this right here is basically 20. So that's 20. Then we times this with math cos and in the angle. And this is why we used radians right here and not degrees, because if this was 90 degrees, then this would be way off. So we are using radians to give it a much smaller value to work with, because 90 would be pretty big compared to 1 point something. Anyhow, so then we can say math.cos, and in here we can specify the angle, and the angle, as we know, is math.rad90. So math.rad90, like that. Okay, so we got our values. Now we have to times these two together. So 19.99999 times 6.1232339, I believe. That will give us this right here. And then we can add our self.x, which would be 200. So this value right here plus 200. Now that we have that, we can see where the next dot will be drawn on the x-axis. So here we have our x, and this right here, that's 200 to the x. So that's 200. Now the next one will be 322. So that would be even further beyond. So that would be like here or something. And not downwards, it's just the x part. So like it would be like here or something. There. And this is where this one is. And you can just imagine that these two are 120 pixels from each other. Now with the Y, it will position this one downwards. So you can use this to kind of figure out where everything goes if you were to do the math like this. This is at least how I can understand math. So if I want to spend the time, this is how I would understand it. So we can draw the player. That is good progress. We can't do anything yet, but we can draw the player. Nice. Now, we still have a debugging option. So let's quickly implement that. So right underneath opacity, we can say if debugging, then, and here we can say love.graphics.setColor, and you can make this any color that is not white or black. So 1, 0, 0, because black is the background and white is the color of the ship. So making it a different color will make it easier to see. So in this case, I'm making it red. And then love.graphics.rectangle, and we want to actually see the center of the ship. This will just help for debugging for when we try and move the ship and the ship maybe doesn't move but the center moves or something like that. And here you can just say fill, and then self.x minus 1, self.y minus 1, 2, 2. So this positions it in the center, and I'll show you in a second what this means. So if we do this, as you can see, we have a little red dot in the center of our ship. The reason I said -1 for the X and the Y position was because if I didn't, we'd be getting this. And as you can see, it's a little bit off from the center, and we don't want that. And the reason for that is just because of how we draw. So we add -1 to avoid that. And in the 2 is just the size. So if we were to change this to 4, for example, then now we'll get a bigger circle. And now we'll have to change it more to the side because of the size here. So this will now have to become -2, -2. So the more you increase the size, the more you have to move it back. Because you have to remember, if I were to open my drawing app again, if we have a square like that, this is the X position of the square right here. So right there, that's the X position of the square. And we are drawing a rectangle inside of the player. So we need to minus this to the X and minus to the Y to bring this to the center of this square, if you understand what that means. Anyhow, so let's just change back to 1 and to 2. And then next I want to draw the collision of the player. So when we try and collide with other things, we can see where the collision would affect each other. So love.graphics.circle, and here we can say line self.x, self.y. We can say self.x and self.y because the x and y of a circle is in the center of a circle and not at the side of a circle. And it's self.radius, so the radius of the ship itself. If we run this, we get a circle around the ship. Now this circle right here is basically the collision. So if anything touches that circle, it's touching the player. You might think this is pretty basic and it is moving things and it isn't quite accurate, but believe me, this does decrease the amount of math we have to do, and you'll thank me for this later. Alright. Now, whenever you don't want to see that, you can just turn off the debugging by passing in false here. Cool. Now, let's move the player. Because currently the player isn't moving at all, and we can't move the player even if we wanted to. So let's create a function, and we can call the function move player, or just move. Both will work perfectly fine. We can then say function that takes in self, and then local FPS. So this will get the FPS of the game. So this isn't the best way to say how fast the player should be moving. And we could possibly change this in the future to be a better way. But for right now, saying the FPS will be the easiest way. So we can say love.timer.getFPS. And we can of course scroll a bit down. And then we want to set the friction. And the friction will just basically say how fast the player should stop moving. So let's go here and say local friction, and we'll play around with this because it's pretty simple, is equal to 0.7. Now we need to set the rotation speed of the player. Now I want the player to be able to turn a full 360 degrees, so completely around within a second. To accomplish this, we can say self.rotation is equal to 360 divided by 180 times math.pi divided by FPS. So first, there we go. So first it will execute this and it will get the value of this. So Lua 360 divided by 1080, that's 2. Then it will divide these two. So math.pi divided by FPS. So math.pi, and we can assume we'll be getting 60 FPS. So that's 0.052. So that's 2 times 0.05235, like that. And that should be a times symbol, not an and. And they will get this value right here. Now this value right here is basically how much the player will turn every second. Cool. Now let's actually use that because I think it would be easier to understand if we use it. And don't worry too much, there won't be that much math in this course. It's just the first one has quite a lot of math because we're using a triangle and whatnot. So you don't have to worry too much about the math. We want to basically say when the player should be turning left and right. So to do that, we can go here and do a quick fix to that and say love.keyboard.isDown. And we want the player to turn left whenever they click on the A button. And you don't have to add these extras, but I like to add options. And we can say, or if they press the left button on their keyboard. So that's like the left arrow on your keyboard. Or if they press the KP6, and that's the numpad number see, that shouldn't be 6, that should be 4. So that's numpad number 4. So if they're on the numpad, they press 4, then the player will also go. So now they have a lot of options to choose from. You don't have to add this many. I just like to. And you can say self.angle is equal to self.angle plus rotation. So every time this runs, it will add this to the rotation. So it will add 0.1047 to this right here, and that should be self, to the angle. So the angle will change every time. And as we know, the angle is in radians, so we need a small value, which we got here. As you can see here, we got 0.147, and we add that to this. And you'll see it working in action in a second. We can then copy this, and we can then go here and say D if they want to go right, and then right for the right arrow key, and then KP6 if they want to go right. And in this one will of course be minus. Cool. Let's test this out. So if I were to run this, and of course we don't do anything yet because we have to go here into the main file, and we have to say player move. So right here, player move. So it should execute this every time this update runs, which is like a lot. 60 times a second, in fact. Run this. You'll notice I can now rotate. So that's pretty cool. And it takes me a full second to do a full rotation. Now, of course, if your FPS fluctuates, like you have 30 FPS, then the player might actually rotate faster than a second. So that's why I don't like using the FPS. But for right now, that's the easy way out. And we don't really use DT at the moment, but we can later. Nice. Now let's add a movement so the player can move up and down. Now we were not going to add the keyboard bindings for this in here. We're going to do it out here. The reason for that is because we will be using that for more than just the player. Anyhow, so then we can go if self.thrusting, and we set that up here, which is just true or false. So if the player is moving, or if the player is trying to move, so if they press W, the thrust will be true. Then, and here we want to start moving the player. So self.thrust.x, and this thrust.x is set here, is equal to itself. Whoa. And then we can go plus self.thrust.speed, and we get the speed from here, which is 0. And it shouldn't be 0 now that I think about it. It should be 5. You know, you should give it at least some speed. So the faster you make this, the faster the player will move. So the higher this is, the faster the player will move. And here we can say times math.cos self. And this is just to kind of nerf the speed. And we can actually remove this in a second. And then divided by FPS. And then we can copy that again. And this time for Y. And then we still everything the same. But here we can go minus. And then we do sin. And there. Now currently won't do anything. So let's try to implement that. So right here, between the load and update, we can say function love.keyPressed. And we can say key. And this will allow us to add a key press. Then we can say if the key is equal to W or, and now we can add a bunch of extra options. Yet again, you only need to add one. I just like to give choice. And here we have 3 options. One that will be the up arrow on the keyboard, and then KP8 for 8 on the numpad. If it's one of those 3, then player.thrusting equals true. So it will make the player thrust. Now we play it, we don't really get anything. And the reason for that is because we're not applying this thrust. We should apply this thrust to the X position. So self.x is equal to itself plus self.thrust.x. So you should apply the X amount of thrust to this. So let's just copy that and do the same for Y. Now if we run this, as you can see, he moves, but he just kind of moves out of the screen first of all. And as you can see, also just constantly speeds up. That is because frosting is always on. Now it would be even worse if we were to remove this right here, because that nerfs it a lot. So let's go here. And now if we were to run this, as you can see, he moves up super fast and even optionally in the wrong direction. But yeah, so this just nerfs it to be slower and moves to the correct direction. All right, and you can play around with that. Next up, we need to be able to slow down the player. So else, then we can go if, and you could make this an else if you wanted to, but I like to just go else and then if inside of it. self.thrust.x, if that is not equal to 0. So the thrust x is still running. And the same with the y. So or, because if the thrust x and y is not 0, that means thrusting is still continuing. And we're going to go here also not 0, and that should be y. Then we should decrease it until it becomes 0. So self.thrust.x is equal to self.thrust.x minus friction times self.thrust.x. So the higher this friction we set here, as you can see there, the faster the player will stop. And of course divided by FPS. And we can do the same for y. Cool. Now let's implement that. Because currently when we press the key, we set the thrust to true. But it doesn't do anything after we set the key. We should actually tell it to stop thrusting at some point. So let's go here. So if the key, instead of pressed, we can go key released. And this means once this key is no longer being pressed, so being held in, we want to turn this to false. Cool. Now we can run this. Let's see. And as you can see, it moves much slower and he actually stops. So if I go like that, it will stop at some point. Now just to give you an example, if we were to go here to friction and up that to, let's say 1.7 and then go, then as you can see, he stops a lot faster. So the player now just almost immediately stops because the friction is so high. If you want to do the real space game, you can make the friction something like 0. Now, it will always just move forward. And this is how Asteroid actually is. The player never actually stops. So this friction just says how fast the player should stop moving. 0.7 I found to be a fairly decent value. It's not too fast and it's not too slow, but anywhere around that will work. Cool. The last things we need to do is we want to reset the color. So if any color changes happen, we want to reset it. So love.graphics.setColor and then 1, 1, 1, 1. So it's all visible and it's all white. And then of course, we want to actually, just for debugging purposes, show the FPS. So love.graphics.print love.timer get FPS and then 10. So it will print the FPS right here around the top. Now if we run this, we can also see your FPS. Comment down below what FPS you are getting. And yeah, that is that. We added the player and the player can now move. So we have this. Oh gosh, my bad. That's a bug we might want to fix. Okay, there we go. You see the player moves. And the player stops at some point as well. We should also at some point just implement something here so the player can't go off the screen. But yeah, and that's that. Thus, we are now going to be working on this right here. A little thruster that animates and moves up and down. Basically showing you that you are basically thrusting yourself through space. So we'll be implementing that today. At least it's not as much math or massive blocks of code as in the previous tutorial. So no need to worry. First of all, we can close this main.lua. We'll be focusing mainly on the player. Cool. Now I would like to add 2 more attributes here to thrust. First, I would like to add big flame. And big flame will basically determine when we change our flame size. We'll make that false by default. And then also flame, and then 2.0. And this will just help with the animation of the flame, where it goes from big to small and from small to big. So that will just help with that. So first we need to actually draw the flame. So let's create a function for that. So right here we can say draw flame thrust. Now you'll notice in the code I will give you, you will see this. But I actually want you to, instead of going underscores, go camel case like this. I am not going to do this because I am following a script and I can't really change that script now. It's a little late. However, you can still change it. Why do we do this? Because this one here is using camel case. This here is using camel case. This here is using camel case. So we want to basically stick with everything using camel case, except for, of course, these constants. Now I've already scripted it, so we have to use this, but you can still change this to be camel case. I just accidentally messed up. But that will be a function, and it will take in self the fill type. So this will basically say how we're going to fill the thrust on the ship, because this will basically automate a lot of the drawing process for us. And then as well as the color. Now we can actually take this and we can copy that and paste it here, and of course add a comma here. And we'll get to editing this in a second. First we want to set the color, so love.graphics.setColor to color that was passed in, because we will draw more than just the inside of the flame. We'll also draw like the outside of the flame, so we'll need to set the different colors and whatnot. And in here we specify the fill type, which can be either fill or line. So when we use this function, it will either draw a line or fill it for us. Now this will change a little bit. So here we can say self.x minus self.radius, because this will have to be an upside down triangle. So self.radius times, and it's basically going to be the same in most regards. So 2 divided by 3, a little bit different, but still relatively the same. Just instead of 4 divided by 3, we're using 2 divided by 3, because now the triangle tip will be at the bottom and not the top. So we say 2 divided by 3 times, and we can take this math.cos self.angle and paste that there, and we can say plus 0.5 times math.sin self.angle. Now you're basically throwing the thing on its head, so don't worry too much. And we can copy and paste that. So now we have self.y, and instead of minus, this will be a plus. So plus, and we can remove that plus there. Then it's a self.radius, and this should be times, not that, so times 2 divided by 3, then math, and instead of cos, this will be sin for sin, and then this will be cos. So we're swapping those two, and instead of plus, it will be minus. Then we can copy these two. Actually, we can just copy the first. We can paste it here, and this should be downwards. Then it's self.x minus the radius times, and this time we want to basically set the flame of the thrust. So right here, that will help with the animation. This will basically draw the flame a specific size. We can remove this whole part for that. And in between these, we can say self.thrust.flame, like that. And why did I do that? Let's copy that. And then here we can just replace. There we go. And this will be cos, not sin. We can then copy that and do the same for y, but yet again just invert everything. So minus will become plus, and then we're good to go. But after we turn cos to sin. And then we can copy these two and we can paste them here. Now they will basically be the same thing, but this time we just go from plus to minus and from minus to plus. There we go. That should theoretically draw our flame thrust, but we haven't tested yet, and that's quite a lot of math to draw a polygon. Luckily, this should be one of the last polygons we draw. Not the last, but one of the last. Now, we can go to draw. Now, we only want to basically show the thrust when we are moving forward. So did we include? Yes, we did include thrusting. So only when we move forward do we want to show the thrusting. So to do that, we can go if self.thrusting, then, and then here we can draw everything we need for the flame, of course. Now we need to check, is it a big flame or is it a small flame? Because we can have two different flames, a big one or a small one. So we can go if not self.thrust.big flame. So we're checking if it's not the big flame, so if it's the small flame. Then we say self.thrust.flame, and you can find all of these right there. And we can make that equal to itself minus 1 divided by love.timer.getFPS. The getFPS is just to basically give us a bit of animation. So in this case, it will be -1 divided by 60. And this will just allow us to resize it for the animation. And remember, this draw will basically also run once every frame. So you just have to remember that as well. That's how we can get this animation rolling. And then let's leave that for there for now. And just say self dot, or not self, not dot, but colon, draw flame thrust. First, we want to say fill because we want to fill it. And next, we can draw the flame color. In this scenario, you can even make the flame color change depending on its size. That's actually a cool feature you can add in the future. But for right now, I'm just going to give it a static size or a static color. So 255 divided by 255, then 102 divided by 255, and then 25 divided by 255. And this will give us an almost red color. Now if we save this, I wonder if we'll be able to run it. Attempt to index field thrust a nil value. So let's quickly just comment this out before we continue. And as you can see, we have a flame. It's not really animating, but we do have a flame. And that's basically what we are drawing. And it only appears when we're moving forward, so when we're thrusting. So that right there, if thrusting. Cool. Now let's draw the outer line of the flame before we continue. So self, draw, flame thrust, and instead of fill this time, we will say line. And now you'll notice why I did it like this and not just put it here. Because we're going to use it 2 times. So why have that code twice when we can have it once? And then we can set the color. And this time, just to give it some variety, but usually you should stick with one type. So if you're using RGB like that, then you should keep it like that. But this is just to show you, you can have multiple. So 1, 0.16, and 0. Now if we were to run this, you'll notice it has a little bit of an outline. Not very noticeable, but it does give it a nicer feel. Cool. Now we can start resizing it and making it feel pretty cool. And here is basically where our problems began. This should be thrust, like that. So I kind of messed up the spelling there. Now if we were to just run this, you'll notice the flame just kind of goes weird because this resizes the flame. That's actually kind of cool. That's like a sword. I like that. Anyhow, so this basically resizes it to become smaller. Because if we're saying big flame, we want it to become the bigger flame. Now to make that happen, we can go here and say if self.thrust.flame is less than 1.5. So if the size has gone to smaller than 1.5, then self.thrust.bigFlame, because we want to make it start giving the big flame. Why do I constantly, did I misspell this somewhere? No. Thrust, there we go. And then big flame equal false. So basically, once we reach a certain size, we want to start growing the flame. So we're making big flame equal to false. I mean true, not false. Because we want to start changing the big flame, or to the big flame, so it can start becoming bigger. So now if we start flying, you'll notice at some point it stops shrinking, because we're not calling that anymore to make it continue shrinking. Because of this right here. Because we only run this if this right here is false. In this scenario, it's true, and by default, it's false. Now we need to do the opposite to get this to grow again. So we can say else, and there shouldn't be no colon, this isn't Python. And now inside of this else, we can copy this, just paste it there. And now instead of going -1 to decrease it, we should +1 to increase it. And remember, we're dividing it by 60 so it stays small, because 1 divided by 60 is pretty small. If we go here, and 1 divided by 60, there you go. So it will basically increase with this amount. Of course, you could put a specific value in here, but this will also make it grow/shrink depending on the FPS. Not the best way to do this. I would recommend instead using DT, but we can maybe try that later. And in here, instead of 1.5, it should be 2.5, and then false. So once its size reaches 2.5, and it should be more, not less than, then we should turn this to false, and it should start doing this one again until the flame is a specific size, a small size. Then we change back to this one, and we're doing that toggling with this right here, setting to true or false, and in here we're checking if it's true or false, and then executing depending on the size, or depending on if it's true or false. Now if I were to run this, you can see it now grows and shrinks. Now you can make it grow and shrink less. It's up to you how much you want it to grow and shrink. To me, I think that's a nice amount to grow and shrink, but you know, everyone's eye will be different and feel different about it. Now, one thing I also want to do, because that bothers me quite a lot, when we move this ship like this and it goes off screen, I can't get it back. Unfortunately, it is now gone forever. I don't know how to turn that ship around and get it back the right way. So what we should do is we should implement something to fix that. Now to do that, let's go all the way down to right underneath this, and we can say if self.x plus self.radius is less than 0. So self.x plus the radius. So let's actually open up my drawing app here, because this I can explain. Pretty simple math. So here's self.x, right here in the center of the circle. Now the radius would be from this part to this. So let's actually draw a bigger circle. So here we go. And then there. Now the radius would be from here to here. And you might be wondering why I'm drawing a circle. The reason for that is, as you can see, the collision detection. It's a circle. This also allows us to get this right here. Now if we say plus, it's going to add these and give us this position right here. So let me actually mark that in red. This position right here. Now when this position goes off screen, so if this point right there goes to behind this here, so off the screen, where we can't see this at all anymore, we want to make the ship come out from this side. So now it's going to come back here. So the ship will start flying here. Imagine this is the ship. Because the ship's radius no longer on the x-axis can be seen, so we can just as well bring the ship in. If you want to make it more complex and you think you have the guts to do that, you can make the ship start getting drawn once it has reached halfway, or even make the ship get drawn immediately once it reaches in here. But that's some math I do not want to bring into this video. Anyhow, so let's do that. So I can say if, wait, we already said if, so self.x, and we now have to change it because it went away here. So we now have to make it come back here. So that will be equal to love.graphics.getWidth. And we say this specifically because remember, the window plus its width is this part of the window. So it's going to be the end of the window. And then we add plus self.radius. This just makes it look more natural once we get here, because then we'll come in more naturally instead of just boop appearing. But of course you can make this more complex and make it work cooler. So let's see if that works. Oh gosh, that's a weird bug. Anyhow, here we go. Ready? Oof. Get width. Cannot call it. And that should be a dot. My glasses obscure my vision. My bad. Now if we try it, let's see. And there we go. It looked normal. The reason it looked normal was because we made it only start appearing there once we've reached with the radius. So it will add a radius to it and then it will appear. So it will look more natural. But of course, if you were to remove this, then it wouldn't look as natural. It would just kind of plop into view. So if we go here, pop, it looks natural, but it still pops into view. So it's not like it's animated or anything. It's just pop. So it's not the same. Anyhow, so there's self.radius. Now we need to make it do the same for all of the sides. So we did this side, but we need to do this side as well. So we can just say else if, and we can specify self.x minus self.radius. We're minusing this time because here we have our ship and here's the port. Now we're minusing the x, so it's going to go here. So this is where we're checking now. And now we're going to check once it goes out of the screen here, if this part is no longer in the screen that we can see, so in the window, it's going to start appearing here and the ship will start flying here again. So it's the same thing, but this time we check for this side instead of this side, and we check for this side specifically where it comes in here instead of the other way around. With this map, I highly recommend playing with it, because believe me, it can boost your understanding of a lot if you play with it. And since we know this gives us the end of the window, we can just go if it's more than this. And now we can just copy this self.x, and actually we don't even need to. We can just say self.x is equal to negative self.radius, because here we added the radius, but now it should be 0 minus the radius. So you could say 0 minus self.radius, but that wouldn't make a lot of sense, since by default negative radius would be, so if you say 0 minus 30, that will give you minus 30. But if you just said minus 30, it will still give you minus 30. Anyhow, so now we should be able to go with both screens. So if I go here, or with both sides. There we go. There we go, this side. There we go. So that's pretty neat. We can do the same for Y by just copying and pasting and then transforming all of this to Y instead of X. We can still add the radius because now the radius will add downwards and upwards instead of left and right. And instead of get width, we now have to say get height. And this will basically do everything for us. Now we go here, bloop. Now we can turn it around, bloop. Now we can't go off the screen, which is nice because we don't want to go off the screen. We want to keep coming back. Now in this tutorial, we will be adding the game state. It's nothing you can really see, so I can't really show you an example of it in game. However, this will make our life in the future a lot easier because now we have something to manage the state of the game instead of us having to do it manually. So let's open up this main.lua. So we have it open. And let's actually just create the game state. So let's create a folder called states. And inside of that, a file called game.lua. Game.lua will contain our game state. Currently, it will not really do anything, but it will in the future do a lot. So we can say function game, and then we can just return game. Then inside of here, we can just return. We have nothing else we need to really do. And we can just return a few things. First, I want to return all of the states we have in the game. This means we will have a menu state, which we'll code later, a paused state, which we'll code later, a running state, and an ended state. And we'll code the ended state later as well. We already have the running state. So we need to define those states. So state is equal to, and then menu can be false, paused can be false, running for now can be true, so it's going to be the default state, and then ended, which will then be false. So these are our 4 states. You can add more states later on as you please. Thanks to this snippet of code here, it's not too difficult. Now what might become difficult is switching between states, such as saying, okay, we don't want the menu state anymore, we want this state. We want to switch to paused or to running state, and later on switching that state to the menu state. All of these things, they can be kind of difficult to implement. So we are going to take the easy way out and implement something that does all of that for us. So change game state is equal to a function and in the state we want to change to, so state. We can then go self.state.menu is equal to state, and if that is equal to menu. So if the text menu is passed in, then we're switching to the menu state. And we can do this for all of the states we have. For example, paused, running, and ended. So here, 1, 2, or just 1, 2, 3. And in here, 1, 2, 3. Now there's probably a better way than to implement it with a string. But a string for our basic game is perfectly fine. As long as you don't misspell something, you'll be good to go. But you could give it a default state if none of these are true. But we're not going to worry about that. Now that we have this game state, let's add it to the game itself. So right here underneath player, we can add game is equal to game. And of course we need to import game. So local game is equal to require, and as you may remember, it's inside of the states folder. So states, and we're going to go .game, we can go /game. This should import it into this project. Now we can go down, and here with the update we can now implement some of this state checking. So if game.state.running, then only we want to move the player. So we can move that in there, and we can move this to the top. So now we have that. So only if it's in the running state can we move the player. So if it's in the menu state, or if it's in the paused state or the ended state, we cannot move the player. Then the only other time we might want to have a different state for right now can be in the key pressed. So we can copy this if statement, and then if the game state is running, then do this. And then if the key is equal to escape, then we want to go game and then change game state to paused. And this will make it go to the paused game state. Now we need to be able to change it back. So let's go here and say else if game.state.paused, and then we can just copy this so we get the same key input, and this can change it back to running. So one of the things I left for homework in a previous video was to implement a paused state for the game, and I told you it would be really easy to do so. And right now we have implemented a paused state for this game. So if you were part of the previous tutorial, then now you should understand how to do that if you didn't do your homework. So yeah, this is how you would implement a paused state. It's incredibly simple. Now if we were to run this, we can go like this, and if you say pause by pressing escape, then the player doesn't do anything. And once we unescape, the player will continue. And then like this. And later on we can add like some paused text, but for right now it's fine. In this tutorial, we will be adding text to the game now that we have the state implemented. So what we have currently is something like this. So where we go like this, and we can also pause like that. Pausing isn't perfect, but you get the idea. Now, when we pause, I want the user to actually be able to see that they paused, because let's say they accidentally press the escape button and suddenly their game stops working. They will think it's a bug, but in fact the game is being paused. So we're going to implement that, and here's an example. Let me just bring this over here. So let's go like this and then pause. As you can see, there's no paused text on the screen. And now we go like this. It's nice. Cool. So that's an example of what we'll be doing. Now let's get started. So we already have a states folder. Let's create a new folder for components. And this folder will be used specifically for components that we might want to use in the game. We'll also create another folder, and this one will be for objects. Now, the states contains the states, is the menu, game, those types of states. The objects will contain objects that we can touch, so the player is an object. And in the components is basically like the text. It's not necessarily an object that we can crash into with the player or something like that. So yeah, now with the player, we can move the player to objects. There we go, move. Then here we want to say objects player, since now the player is in the objects folder. We don't actually use the player here, so we don't have to worry about it there. If we run the game, everything should still work fine. Cool. Then the components, we can create a new file called text.lua because it's text. We can close this main.lua, and now we can start working on the text. So first let's local love is equal to require and just love. Then we can create a function, call it text. It will take in some data and then it will return something. Of course, a table. And then at the end, we can just say return text. There we go. Our basic text object setup. Now we need to think of properties that text may have. So let's actually split it up into a few things here. Let's go parameters. Now first, I think all text will have some text, which would be of like a string or a text type that will be displayed. And this text will be the text to be displayed. And it's required. Now, you might ask, why am I doing this? Like, what does this benefit us with? If I were to hover over my text, you'll notice now we have parameters. Text, string, text to be displayed required. This is called documenting your code. So if someone else in the future comes back to our code here, they will be able to just hover over a function wherever we use it and see what it needs. So that's what I'm doing here. If this wasn't here, then as you can see, we don't get any description. So that's what I'm doing here. Now, this is quite a lot of we're going to have to type. So since I'm too lazy, I'm just going to paste this from the already existing script code. There we go. We need an X for the X position of the text, so from the side of the screen. A Y for the Y position of the text from the top of the screen. All of these are as far required. We also then want from here everything's optional, but we also want the font size. The default will be P, and I'll set up this in a second where we'll actually have some default versions. If you know HTML, then this will help you greatly. And here are some of the options we can use. We then have a fade in, which will allow us to fade in the text. So let's say if it's a game over, we want the text to fade in as well as the text to fade out. This is just a boolean, so true or false if it should fade in and or fade out. Wrap with. This is when the text should be broken. So this should be when should the text break. The default would be the window width, but you can change this and you'll see later where we can change this. Then there's the align. So where will the text be aligned on the screen? It's like center, left, right, all of that. And then the opacity. Basically, this will allow us to set a default opacity for the text. So the text should maybe be a little bit see-through or something along those lines. We can now implement that in here. So we want the text, the X, the Y, the font size, the fade in, fade out, wrap width, align, and opacity. Quite a lot. You don't need all of this, but I feel like giving as much choice as possible is always a good idea. Now here above return, we can set some of the default values. So you can also do this in return if you want to, but most of this will be useful outside of it. So font size is equal to the font size that has been passed in, or it will default to P for paragraph, so paragraph size. We can then just create a space and copy 5 times. We then want fade in, fade out, so fade in, fade out, wrap with, align, and opacity. So all of these. So every one that's optional. Then we want to replace all of these with those values. And of course these as well. And in the fade in would by default be false. This will be false. This wrap with will be love.graphics.getWidth. The line would be defaulted to left. So right here on the screen, you can make it center so it's in the center, or you can make it right so it's on the right. And then the opacity here will default to 1. Now we also want to set some constants. First, we can start with the text fade duration because we won't use the fade just yet. But doing all of this setup beforehand will save us a lot of time in the future. But you don't have to do it right now, but I do recommend you still do it right now if possible. Local text, and this is going to be a constant, so it will be all caps. Fade for text fade duration. We'll make that to 5. Now we have the problem here of this right here. How will we set that? Now we can do that by creating something that can hold all of that. So local fonts, and here we can specify the fonts we want. For example, H1 will be the size of love.graphics.new font, and we can make it something like 60 for like 60 pixels. We can then copy that 2, 3, 4, 5, 6, 7 times. Then here we can just go H1 to H2, 3, 4, 5, 6 and make this P. You can add more. You can also use a different structure. I just think that, to me at least, this makes sense since I use HTML. And in HTML, H1 is the biggest text you can have, unless you modify it with CSS. But it's the biggest text you can have. And in P is like regular small text, just regular text. P is also about 16 pixels. And in H6 is usually smaller than P. H5, H4, H3, H2, and then H1. There we go. So there's all of our text sizes. We won't use all of them, but they exist if we need the variety from them. You can also give them different names if that's what you're into. We also want to set if fade in. So if we try to fade in, then you want to give the default opacity actually a lower value. Because if we want to fade in, then the default opacity should be pretty low. Since we want it to fade in, if the default opacity is 1, it's not going to fade in, it's going to pop in. So opacity then gets overwritten to 0.1. So no matter what they put in here, if we say it's fade in, then we're going to force it to fade in by making the opacity 0.1. Cool. We have now done all of this setup, so let's use what we have here. First, we can go and say text is equal to the text that was passed in. X, not dot love. X is equal to the X. Y is equal to the Y. And opacity is equal to the opacity. Now, whilst I could put all of this inside of here as well, currently I don't think I'm going to use any of this outside of this text. So I'm going to keep it here since I'm not using it outside of this text. But if I do, I can move this, for example, the opacity that I moved here, I can move it to down here because what's in return is things we can use outside of this right here. So we can't use this or this outside of this text function. However, we can use all of this outside of the text function. Now we can also set our default colors for the text. So colors is equal to R, which will be 1, meaning basically full red, G, which will be 1, and then B, which will be 1. So red, green, blue. And since they're all 1, this also means that by default they are white. So the text will be white on the very dark black background. Now we want to also be able to set these colors at any point. And you could move these colors here if you don't think you use them outside of this text function. But here we could go set color equal to, and we can create a function. This function will take in self, red, scroll down, green, and blue. Then here we can say self.colors.r is equal to red, self.colors.green is equal to green, self.colors.blue is equal to blue. So now if we use the set color, it will set the color to whatever we pass in. So we don't have to type this out every time we want to set the color. And now for the last function that we'll implement, and then we'll wait a while before we try anything else, is the draw function, because we still need to draw the text to the screen. That's a function. Function takes in self, and now we basically need to say what text we want. I'm going to call this TBL text, because the text will later be stored inside of a table, and also index. And this table is what we're also going to pass in here with the index of what we want to use. You'll understand this in a second once we use it. We can then go if self.opacity is more than 0. They want to do a bunch of things. Else, if the opacity is not more than 0, then we want to say table.remove. And we want to remove from TBL text the item at that index. That should be T. Basically, this is for our fading stuff. So once it fades out, we want to remove it from the table, because if it's still in the table, let's say after 2 hours of playing the game, that means everything that was text is still in the table 2 hours later. And every table requires RAM, and the more RAM you use, the worse the game will perform. So if the user plays the game for, let's say, 10 hours, then by hour 10, their game will probably reach like 5 FPS or something. But yeah, and we can just return false, because that means there's nothing left to draw. Otherwise, we can return true, because there's still stuff left to draw. Okay, now here we can start with the drawing things. We can leave the fading stuff for later. So let's first go love.graphics.setColor, and here we can say self.colors.r, as will give us red. Self.colors.green, and then self.colors.blue. And of course, self.opacity. And this will set the color of the text we currently want to draw. Then we want to set the font of the text we want to draw. So love.graphics.setFont, and then we can pass in fonts, and then at the font size. So the font size we can find right here, which will be something like P or H1, and we pass that in here to get the font size. We'll play a little bit with this to kind of get the idea of what it does. Then we want to say love.graphics.printf, specifically printf because of how much it allows us to modify, how much we can like just do things our way, like customization. So first we want to specify the text as self.text, and then self.x for the x position, self.y for the y position, the wrap width, and then the align. So as I said, you don't have to make a lot of these things you need to pass in. That's why they're optional. You could just hard code them in here, but I wanted to make it more robust. I think that's the word. Then also, after we have done all of this, we want to change the font size back to P, so we have a standard font size everywhere. Now that we have this, I think we can try it out. And then once we have tried it out, we can implement the fade in and fade out. We won't use it yet, but we'll implement it. So let's go here inside of game, and let's create a draw function inside of the game. Draw is equal to a function self, and also faded. I'll explain that in a second. So first we can say if faded, then text, and this text is what we need to import. So we can actually just go here to main, copy this import, go here, paste it, but now we can say text, and text comes from components / text, and we should just say dot dot and then a slash to specify go back one directory, so one folder. Since we're here, we want to go back one folder and then jump into the components folder. That's what this means. Those two dots means go back one folder. Also, we can just say local love is equal to require love. So yet again, it's not required to specify this. It's just optional, but I like specifying it anyways. And then down here, we can say text, and we can pass in a bunch of things. If we hover over text, then unfortunately we don't get any of the documentation we wrote. This probably still needs to import all of that, but for now it's fine. So the text we want to display is going to be paused. Then we can say 0, and that will be for the X, and then love.graphics, scroll down a bit, .get height, and we can just say times 0.4, and this will kind of position the height in the center of the screen. We don't say 0.5 because you should remember that the very top of the text is actually where the text gets drawn. So if we put it at 0.5, it's actually going to be drawn underneath the halfway mark instead of in the middle of it. Here we can specify the size, for example, H1. We can specify false and false for the fading, and then love.graphics.get width, and this is for the word wrapping, and then where to align it to, and in this scenario, center. If we run this, or if we not run this, but we then can go and say draw. Now, if we run it, we won't get anything, because we need to actually now use this draw inside of main. So down here, if we scroll, we have a player.draw. But now we can actually use our states to our advantage. So we can say if game.state.running, or if the game.state.pause. So if it's one of these two states, we want to draw the player, as well as game draw, game.state.paused. So we are passing in this game.state.paused. The reason for it is because game.state.paused is a true or false value. So currently, if we go here, then we are trying to get a true or false value. So if it's true, then draw this. If it's false, don't draw this. We'll expand on this more later, but for now, this is fine. Alright, so now we're saying draw, and it will basically execute this right here. And if the game state is not paused, it will not draw anything inside of here because faded will not allow it to. It's faded because we're going to change it later. But yeah, for right now, we can just say love dot and see if it works. Okay, now let's go and pause. And there we go, we get paused. Isn't that absolutely amazing? So that's pretty cool. Let's make the text a bit smaller. Let's go, instead of H1, we say P. If we run that, then the text is now super small. So we made it able to change the text size by literally just changing one line. So change that back to H1 to make it nice and big. Now, this is more for the future. Currently, it won't benefit us a lot to type this. However, in the future, it will definitely benefit us to have this. So let's go here underneath opacity and say if fade in, so if we should fade in, do something. Else if fade out, so if we should fade out, then, because we don't want them to both happen at the same time, so we're using an if-else statement. So if fade in, then we first do fade in, and then we can change fade in to false, and then do fade out, because we don't want two different if statements. You want one if statement that just has an else if. So if we want to fade in, they will fade in, but it won't try and fade out at the same time. Then we can go self.opacity is equal to self.opacity minus, and here you can't say 1. 1 is a little big though, because our opacity is a range of 0 to 1. So by saying -1, we'll immediately go from seeing text to not seeing text. So we can divide that by text fade duration. So this 5 right here. So depending on how much you make this, the text will fade slower. And in here we can also just divide it by love.timer.getFPS. There we go. And this will nicely fade it for us, so it looks nice once it fades out. We're not going to use it in this tutorial, but we will use it in the future. Then here in the fade in, we can check the opacity, because if the opacity is more than 1, that means we have faded in. So we now want to fade out if possible. So we can check if self.opacity is less than 1. So only if it's less than 1, then increase the opacity. Else, if it's not less than 1, that means it's more than 1. Then we want to set fade in equal to false. Now that we have set fade in to false here, that means fade in will be false, so this will not be triggered. So if fade out is true, then we'll fade out the text. Then here we can say self.opacity, and it will actually just be the same thing. So let's just copy that. But this time, instead of minus, it will be plus. And now we have implemented fade out and fade in. Cool. Now we have added the text, and we can use this text in a lot of the parts of the game.
And hello everyone, if you're enjoying this tutorial, please leave a like and subscribe for future tutorials.
So currently, if we pause, we have a paused text. If we unpause, then it's no longer there. If we move around, we can move around. But the game is still pretty boring, because currently we can't do anything. We don't have any enemies, we just fly around. We can fly off screen, but we'll just come back, so that's no fun. So what are we going to do? Well, of course we should add the enemy. We should create the enemy, and the enemy should of course be the asteroids. That's the whole reason the game exists, to avoid the asteroids. So let me show you an example of what we will be doing today. We can move this here. There we go. We have an asteroid. We can't really do anything with the asteroid yet, but we have an asteroid. And this is the idea. We want to be able to create multiple of these guys without any problem. You also notice the red around the asteroid, just like with the player, that is the hit zone. So if our player's red around it and that asteroid's red touches each other, then boom, the game ends. And we'll implement that later. Yet again, it's a circle, so it's not super accurate. But the game itself isn't going to be super complex either. If you want to give yourself an extra challenge, you can try and make that more accurate than a circle. Awesome. Now, one thing I want to do before we get into actually coding the asteroid is I want to add a new feature to the game. So I am going to remove this text here, go into player, and I want the player to now, once we draw the player, I want it to take in faded, like that. And once it takes in faded, I want us to decrease the opacity of the player. So here we can say, if faded, then we want to set opacity equal to 0.2. You can make it lower or higher depending on what you want. Now, because we have this faded right here, we can now go to main. And here we can just pass in if the game is paused. If the game is paused, we want to fade out the player. So let's run that and just see that it works. So pause. I don't see much of a difference. Oh wait, we don't pause. Pause is this button. As you can see, the player fades out. So pause. The player is still there, just faded out. We want to implement this for the entire game. So where everything fades out once you pause. Except for the debugging stuff, of course. Cool. Now that we have that, we can also implement it at different places. So let's create a new object. This object will be called Asteroids. You could call it Asteroid, but in the script I made it Asteroids accidentally, so now we'll have to stick with the scripts. But we can say .lua, and now we have an asteroid. But you could call it Asteroid, that would be perfectly fine. We can then say, and we just close this as well, local love is equal to require love I just love saying that, I don't know why. We can then say function and asteroids, and we can just return an empty table and then return asteroids. We have created our basic asteroid object. Now, first we'd want to take in the asteroid's X position, the asteroid's Y position, its size, its level. So depending on the level will also depend on some things that the asteroid might have, and then debugging. Now here we can say debugging is equal to debugging or false. So basically it's going to be either debugging or not debugging. Next we want to set things such as the asteroid's vertices. This is basically how many edges the asteroid will have. We'll play around with this later so I can actually show you an example. So in this scenario, or in this case, we can just say local asteroids. And of course, you can make it something different. If you don't like 10 specifically, you can make it 11, 15, 50, 5, whatever you choose. I'm going to make it 10 because I actually found that that looks pretty good. Then we can also set the jaggedness. And the jaggedness is basically just saying how round the asteroid should be. The more jagged, the less round, and the more epic it looks, but also the less accurate our collision detection will be. So make sure it's not too jagged unless you're going to upgrade that collision detection. But then we can say asteroid jag for jaggedness. I'm not going to spell jagged. I don't know how to spell that, but that's 0.4. But you can make it more or less. I found 0.4 looks pretty good. Then we can go local and then put the asteroid speed, and that is equal to math.random. Why are we saying math.random? Because the asteroid speed itself should be random. Or am I incorrect? Because if all asteroids are the same speed, the game would be less fun. But if this asteroid on the left moves 5 times faster than the asteroid on the right, then that would be pretty cool. Just as an example. We then put in 50, so it gives in a random value till 50. And you can say plus and level times 2. So depending on the asteroid level, we'll add to the asteroid speed. So let's say it's 50 and the level is 5. So then it's 50 plus 10. You could increase this level to something like 3 or 4, and that will also make the leveling system much more difficult, but I'm going to keep it low for now. Cool, and we'll come back to this here at the top. I'm currently just going to go to return for now. We can then specify x is equal to x, so the x that's being passed in. Y is equal to y. Oh, not dot love, oh gosh. That was supposed to be a comma. And then we can say the x velocity. This means how fast the asteroid will move on the x-axis, so from left to right. That will be equal to math.random. And now we can say times asteroid speed, so that's the one we did right here, times velocity. Now velocity will determine if the asteroid goes forward, backwards, up or down. So on x-axis it will go either forward or backwards. On y-axis it will go either up or down. So let's quickly create that. So let's go here. You can say local velocity is equal to -1 by default. Then we can check if math.random, and here we can specify it's less than 0.5, because math.random will give a value between 0 and 1. Then, and we want to say velocity is equal to 1. So it's -1, but if math.random is less than 0.5, then we're going to make it 1. And this will decide whether this is going to move this way or this way. We don't have to worry too much about this now. We're just setting it up. Now you may have remembered, before we continue here, that in my Lua tutorial I did cover math.random, and I did cover how it's not always random. So to make sure that the player doesn't get the same game every time they boot up the game, so the same asteroids, the same way the asteroids move, everything, we should make it more random before we continue here, because I might forget about that. We're going to go to main, and here we can just specify right before the load, right before everything, math.randomSeed, as we'll seed the randomness, and say os.time. And this will make everything more random. It will seed it to make it less predictable. Cool. Now we can go back to asteroids, and we can copy this x velocity, and we can make a y velocity as well for up and down, and it can have exactly the same math. So it may not move the same speed up and down as it's moving left and right, which is what we want. Now we need to set the radius of the asteroid, because on the end of the day the asteroid is pretty much just going to be a circle. So we can say radius is equal to math.seal for math.sealing, so always go up, and then asteroid size divided by 2. And this will give the asteroid's radius. Cool. Now I'm going to leave all of this here for a second, and I'll come back to it a bit later. Let's draw this asteroid, because I'm not really sure if we're getting everything right here. So let's go function self, and also if it should be faded, because if we pause the game, then we can yet again say local opacity, if that is equal to 1, but if faded, then opacity is equal to 0.2. Then you want to set the color to not white, but kind of like a grayish white, because when I think of an asteroid, I don't think of it as a pure white blob just flying to me. In fact, I think of it as a bit dark actually. So let's make it like a grayish color in this scenario. Since the background is pitch black, we can't really make it too dark, because then the player will see it. So you'll notice it's not pure white, as you can see here by these numbers. You can tweak these numbers to kind of fit your need for what you want the asteroid color to be. But yeah, this will determine the asteroid color. Now next we need to determine the asteroid's points. Now the points basically just say where the asteroid is going to be. When we draw the polygon, we have a bunch of points. So you may have remembered when we draw the player. So local points, let's go here, is equal to, and here we can specify a table, and then say self.x plus self.radius, which is right here, times self.offset. Now offset is just so we can get a little bit of an offset, so the game, or so the asteroid, which is like a circle if you remember with the player, it needed a little bit of an offset so the center dot can always be in the middle. If you could remember what we did. So if we go here and say love dot, then you see that little circle, that little red dot in the center of our player. That had to be on an offset, which was I think like -1 and -1, because it wasn't quite in the center of our triangle. And in this scenario, we'll have the same problem. So we're setting an offset. Now to generate the offset, we can go up here and we can say local offset is equal to an empty table. Then we can say for, well not in pairs, for I becomes 1, 2, and to where? To where specifically are we going to set this offset? Well, that depends on the amount of vertices we have. So in this scenario, we have 10 vertices, but we don't want all of the asteroids to have the same amount of jaggedness, right? We don't want that asteroid to have 5 points and then the one next to it also have 5 points. We want one to have 2 and one to have 10 and one to have 4. We want there to be variety. So let's create a more interesting vertex. But you could, if you wanted to, just put this here, like that. That's perfectly fine. But I want it to be a bit more random. So here we can say local vert for vertices is equal to math.floor, because we also want to go down, but you could make it go math.seal. In fact, that might even be better. I'm following a script, but you could make it math.seal and that would work perfectly fine. Math.random, because I want to get a random value. So just right here. So you can pass that in there and just say +1 so we don't get 0. Plus, and then you can paste that Android vertex in there again, divided by 2. And this will give us a nice random value, which will also determine how less round our asteroid is. So how many points it has, edges. Now here, instead of saying this specific just always 10 value, we could specify vert +1. And now we can insert an offset, and this will always generate the offset at the correct location. So we can say table.insert and then the list and value. In this scenario, we want to do offset and math.random, and I'll explain this in a second, times asteroid, and let me just scroll down so I can autocomplete that, times 2 plus 1 minus asteroid jack. The thing is, I can't quite explain this math here because you can't visualize it. That really sucks. But once we see this asteroid, we'll be able to play around with this, and I can explain what's happening. But take note before we continue that this right here is not the same as saying this. They are not the same. Just take note of that for some of you who might want to do that. But there we go. And we can play around with this later so I can show you in examples. But for right now, let's just leave that like that. So we have this vert and offset. And now I can get the vertices like this. So vert. And then offset is offset. There we go. So now we have both of these that we can use here. So back to points. So now we have self.offset, which is basically everything we just did. And now we need to specify at what index, because there will be multiple. Because if you could see here, we're foring through this and inserting for every item. We're inserting a new offset, or a new item for that offset, the new location. So now here with the points, we need to specify. And I'm just going to say 1. So the very first one we have. Times, and we'll later on modify this to be a bit more interesting. Math.cos. Yet again, I can't quite explain this yet because we can't see it, so we don't really know what we're drawing here. But I'll show you in a second. I'm going to self.angle in there. And then with the next one, we can just copy it. And instead of saying X, this will be Y. Keep everything the same, and instead of cos, we say sin. And now we don't have this angle though. You may have noticed that. We can quickly generate something that will give us an angle, just like with our player how we have an angle. We can do the same here. We can just say angle is equal to math.rad for radians, and then math.random, and we just say math.pi. You don't have to worry too much about the math we're doing in this game dev course. The more important part is that you can see how everything fits together to create something interesting in Love. So if the math goes over your head, don't worry. There's a lot of games out there that you can build without all of this complex math. And in most cases, you can do what I do and you can just literally copy math from online, because I watched a lot of tutorials and I looked through a lot of documentation and I was like, I don't understand any of this. I copied, paste, test, and it worked. That's what I would recommend you do as well. If you're not very good at math. If you're good at math, then just do this. Math course coming out soon at some point. So stay tuned if you want to improve your math. Cool, so now we have our points. But we still need a lot of the other points as well. So this is just the first batch of points, because if you remember, we need at least 2 more here in order to complete it into a full triangle. So we can create a for loop, and then for I becomes 1, oh, that should be I becomes 1 to self.vert minus 1. So the amount of vertices is minus 1. Do. And we can just say table.insert. We can specify that we want to insert into points, so this one right here. And then what we want to insert. For now, I'm just going to copy this and modify it because it's quite a lot of typing, because math. So it's self.x plus self.radius times the offset, but instead of saying 1, we say I plus 1, because here we specified 1, but now we want to go 2 and 3 and 4 and 5. If you wanted to, you could just specify that I should be 2 here from the get-go, but this works perfectly fine as well. And then we can specify math.cos self.angle, but now we need to add a bit of extra math so we can close this polygon we're drawing, because remember, a polygon should close. If we just drew a triangle with like just 3 angles, it's not going to close itself. We need to make sure it closes. For example, if I were to open up my drawing app here, if we just drew this 1, 2, 3, that's not a triangle, is it? This is a triangle. A triangle closes itself. So we need to add some extra math to do this at some point, or here, but not this. This is bad because it doesn't close itself, it just stays open. So we need to do some math to do this, like that. So now here, after the angle, we say plus I times math.pi times 2 divided by self.vert. There we go. That should be divided. Awesome. We can then insert another one, and we can just skip over the math for now because there's a lot of math here which we don't necessarily need to cover at the moment. And we can just specify y here. Everything else will stay the same, except instead of cos we'll have sin. Cool. Now we can actually go about drawing what we have. So we can actually display it on the screen and see what we're working with, because currently we're not drawing anything. So we can just say love.graphics.polygon, and now we just specify that we want a line. Oh gosh, we want a line and points, because we generated the points right here. It's inside of a table. We did the points, and now we're passing in the points. So instead of doing what we did with player, where we just passed in the points like this, as you can see here, the math is pretty much similar. We did this instead and generated the points for us, because asteroids won't all have the same amount of points, unlike the player, which only has 3. They might have 10 or 50, we have no idea. And we don't want to draw each one of those out by hand, because that's going to be a massive pain. So we use a for loop to do it instead. Cool, and let's just add some debugging in case you want debugging. So if debugging, then love.graphics.setColor 100, so red. And we can then also specify love.graphics.circle to draw a circle. We can specify we want a line, and then we specify self.x to give it a self-x position and a y position, and then we just specify the radius. And there we go. So this would display the hitbox of the asteroid. Now I still want to implement movement, but for right now I think this is fine. Let's just go to main, because I want to see what we draw. You can probably hear my voice, how excited I'm getting to seeing what we drew. Let's go down here to draw. And now we actually need to generate an actual asteroid. However, I am wondering if doing it here would be a good idea. I say we should rather open up the game state. And we should implement a function that could benefit us in the future. For example, what if we had a function that says start new game? And that's a function that takes in self and the player. And I'll explain why in a second. And this every time starts a new game when we tell it to. So let's say the game ends because the player died, or when the player says play game, then this will trigger and it will restart the game. So you could say self and then change the game state to running, because we were changing the game state back to a running state since that's what's happening. Then we are creating a global scope. Very important to remember this, a global scope variable called asteroid. So _g dot, or just plain out here asteroids, just lowercase a. This is a global scope variable, meaning it can be used anywhere inside of this file, or actually anywhere inside of this game now, because we're going to import this file later. We're going to use this and it's going to generate this global scope function, or this global scope variable. This isn't the best way to do it. Take note. In fact, I might even recommend you do asteroids here and say asteroids and then doing this, or finding even a better place to do it than here. But for now, this will work fine. We make that an empty table. Take note, it is global scope. You will get confused if you do not take that as note. Then we specify the asteroid's current X and Y positions. So you could do this without needing to put a variable, but I'm going to use a variable just to keep things simple. So local asteroid X position is equal to math.floor, math.random. It doesn't need to be random. You could specify a specific position. For example, we could go here and say table.insert, because we want at least one asteroid. Asteroids, and then what index, and then what value. And in this scenario, in asteroids object, we can go up here and you can copy this and change from text to asteroids, change from components to objects, and then here instead of saying text we say asteroids, and this will import this asteroids object which we're using here. And then we specify the X and Y, so you could go something like 60, 100, that's perfectly fine. Then 100 for the, I believe that's the radius. You look here, we go up here. No, that's the asteroid size. So depending on the size, or depending what you pass in there, the asteroid will be bigger or smaller. The level, which will in this scenario just be self.level, so it will level up depending on the game level. And then true for debugging. Now you could do this, but it's boring because we want asteroids to start up at a different location every time we start up the game. So what we could do is we could make it random, and that's what I'm doing here. And we say love.graphics.getWidth, because it's the X position and it can appear anywhere on the X axis. Same with Y, but this time instead of saying width, we say get height. And we pass in the asteroid X, we pass in the asteroid Y, we save that, and now we can go here back to main. Then on the game load, when we create this game, we can say game : start new game, and we can just pass in the player. Now currently we're just passing in the player. This is just for future reference. We don't have to worry about it too much now. But we are passing in the player because later, once we start the new game, we'd want to position the player in the center. We want to give the player more HP, and so on and so forth. So by default, that means we'd want a player. We could also specify and push in some asteroids in here if you wanted to as well. But this is fine for now. Now remember, asteroids is a global scope variable, so don't get confused about what we're doing here, because remember, it's a global scope. Very important to take note of. So for, and we can say underscore, because we're not going to use this. This is the index, we're not going to use it. Asteroid in asteroids global scope. Remember that. You might get confused, so maybe make it somewhere more global or more local instead of global. But for right now, just remember this is global scope because you will get confused if you don't remember. Then you can say asteroids or asteroid and then just say draw. So call the draw function for every asteroid we have. So if we have multiple asteroids, then this will call it for multiple asteroids. And just pass in game.state.paused. So if the game is paused. So if it should be faded out or not. Let's run this and hope for the best. And ooh, asteroid 8 cannot perform on local level. A null value. That means we may not have passed in the level. Do we actually have a level here yet? No, we actually do not have a level here yet. My bad. Okay, so let's add a level. We are currently at level 1. We can start there. Now if we run this. Where's the asteroid? I do not see the asteroid. Let's maybe draw it again. I do not see the asteroid. You know what? I think this could be the reason. So let's remove that 60. I think I just forgot to remove that. Let's try and run it now. And in here we need to specify the size. Sorry, I got so confused of all of these things. But yeah, now I think it should probably... Yes, there we go. So now we have an asteroid. And let's maybe spawn another. That's pretty cool. We can of course have multiple asteroids. Let's just maybe make 4. And then we can just copy this for every asteroid X. And then copy this for every asteroid Y. Just so we can have some of an idea of what we see. Now if we run this, we'll have 4 asteroids that spawn randomly. Cool, and they all look different, and that's kind of what I've been doing this whole time with all of this math.random. This one has 1, 2, 3, I can't actually show my cursor, but yeah. So you can see they have different amounts of like spikes, and the spikes also look way different compared to each other. So let's play around with some of the math just so I can show you what I meant. If we go here to the asteroids, of course, if we were to change this to 90 for example, then now as you can see they're like super spiky. So if the higher you make that, the more spiky they can become. That actually looks kind of cool. But if you were to make this something like 2, then yeah, you need more than 2 to actually be able to draw a polygon. So let's make it 4. I think that should be enough. Then there you go. Then they all look kind of plain. And in here with the jaggedness, you can say how jagged it should be. So if you make it a 9, then it will be like super pointy and super cool looking. But as you can see with the red circles, the hitboxes are not very accurate. So unless you're going to do some extra math there to make it accurate, I do not recommend making this too high. I did put it at 4, but you could put it somewhere else. Like, let's say at 5 should still be perfectly fine. Yeah, it's still mostly perfectly fine, not perfect. But yeah, and then let's say you were to make it a 0.1. Then they'll basically all look super round. And if you make it a 0.0, I wonder what will happen. Would we crash? No, but it would look pretty much very round. And then the more vertices you add, for example, let's say 19, then now it'll look like a normal circle because it's just a bunch of little lines being drawn. And of course, if you were to make this a 9 again, then now it will look super weird. So that's kind of what these were. So if you were confused, I hope this also cleared it up for you. Asteroid speed we're going to work with in a second. Then here's the offset, which you don't have to mess with right now. But if you want to, you could, and you could like remove some things here and see what offset will do. So if we select 10, for example, what will happen then? As you can see, not so great. And of course, if you wanted to, you could say fill instead of line. And that will give you like a filled version, but then I would recommend choosing a color bit more gray than the grayish white color we chose, because then it just looks weird. So I'd recommend something a lot more gray if you want to go something that's not line. Because currently it kind of looks a little bit faded compared to ours. And of course if you pause, they'll all fade out a little bit. And unpause, pause. Like that. Cool, and that's the drawing section completed. Some of you might want to take a break right now. I'd actually recommend it. But if you think you still have the guts to go for it, then let's implement the movement. So here we have not in starting game, but in Asteroids. Here we have the draw, but the draw is now completed for now. So we can now go and say move, and move is a function, takes in self and dt. dt because we actually want to start implementing some good ways to move our objects without using FPS, because as I said, FPS is not a great way to specify how fast something should move. Use dt. And remember, dt is the time between this frame and the last frame, so it's usually very small. Then it's self.x is equal to self.x plus self.x, and we can say vil for velocity, and that's right here. So that will basically, with every move, it will move x to where it currently is, but plus its velocity, and then just say times dt to make it move at a consistent rate. So if it's 30 FPS or if it's 60 FPS, it will get from one point to the other point in exactly the same time. And we can do the same for y, but it's time for y velocity. Cool. So that will move it. Now we can go to main, and we can go up to update, where the game state is running. And we can actually just copy this, paste it here, and this time we can call this AST index. But you don't have to. In fact, you could possibly just keep this underscore, because we're not necessarily going to use it, although we might in the future, so I'll keep that there, because it would make sense to be able to access the index from here. But as for future reference, you could make it an underscore for now. And instead of draw, we say move, and we pass in dt. Where do we get dt? dt gets passed in from update. So update takes in dt thanks to Love2D. We take this dt and we pass it in here. If we run this, then now it moves, which I think is kind of cool. Run it again, now it will move a different direction. Move it again. Now it's incredibly slow. Move it again. Now you'll notice as well, oh gosh, I closed my terminal. But you'll notice as well, when I get back to everything, that if we run it, then it can go off screen. Just give it a second. My player can actually go with it off screen, just to show you something. You'll notice my player comes back. But once the asteroid leaves the screen, it never comes back. We don't want that. So what we can do is we can go to player, go to move player, copy this, go to asteroids, and then just paste this here. And it will do the same thing as with the player. It will make sure the asteroid stays on screen. So let's run this and make sure it works. It's going to take a while to get off screen now. There we go. Alright, give it a second. You can also put some extra math here to make it appear sooner on the other side, but I think this is fine. And there it goes. It now appeared. And just like that, we made sure that the asteroid never goes off screen forever. Cool. And of course, if you want the asteroid to move faster, you could upgrade the speed here. For example, let's just go +9 for now, or let's go +10 actually. I think that would be pretty good. And now we'll move usually much faster, but it is still random. So let's maybe go here and just make it a default 150. let's see, that should make it move pretty fast. Yeah, there you go. So you can just upgrade that to make it move faster or slower. I maybe say increase this ×2 to maybe ×5 or ×4 or ×3, depending on how difficult you want the game to be. This is something you can tweak to make the game your own, to make it something that's just more than what we have. And yeah, that is that. In this tutorial, let's add the lasers. You know, because when you have a spaceship, you can go pew pew pew, and that should be destroying the asteroids. Whilst we'll not be implementing the destroying of the asteroids yet, we will be implementing the lasers themselves. Now the lasers are much easier than you might think they are. They're basically just dots on the screen that move around. So there's not a lot of complicated math in drawing them, it's just a little circle or square that moves. So to give you an example of what we will be doing, let me just go here and start one up. Alright, so here is the example. If I press space, it shoots an asteroid. There's a limited amount of asteroids allowed on the screen. So if you have too many asteroids on the screen, it will remove some of the previous asteroids. But yeah, currently if you shoot an asteroid, it can't, because the lasers cannot destroy anything yet. And I might have said asteroids earlier, I mean there's a limited amount of lasers that can be on the screen, not asteroids, a limited amount of bullets. Alright, it's that simple. Let's first create a new object, and we can call it laser.lua, because this is an object, because it's the laser, it's a bullet. Then right here, we could just remove that, and we could say function laser. Then we want the X position, the Y position, and then the angle it's shooting at, because the player might be at a specific angle, and we want to shoot out of that angle. So if the player is looking upwards, we want to shoot upwards of that angle. Anyhow, then this will return a table, and then we can just return laser. And there we go. Now first we want to set the laser speed. So setting this will determine how fast the laser moves. So how many pixels per second. In our case, I think about 500 pixels a second is perfectly fine. To some of you that might be a little fast, so you might want to turn it down. Or to some it might be a little bit slow. But it's up to you. So local laser speed is equal to 500. So in pixels per second. We can then set the X equal to the X that was passed in. The Y equal to the Y that was passed in. Now let's first draw what we have. So let's draw. That's equal to a function. And this function will just take in self and fade it as well. So if we pause it should also fade out just like everything else. And we can say local opacity is equal to 1. If faded, then opacity is equal to 0.2. Then love.graphics.set color, and you can make this red or green or whatever color you think a laser should be. But I'm just going to make it white. But you can customize the game and make it red, green, blue, purple, whatever color fits your eye the best. You can make everything colorful and much more playful. And we can just also pass in the opacity. Since we are literally just using a dot, we can use a point. So just like a point on the screen. Luckily, Love2D already has this built in. So we can just say love.graphics.set point size. And this is how big the dot will be. I'm just going to say 3, but we'll play around with this so you can figure out what size is perfect for you. Then we can say love.graphics.points. And now we can draw the point on self.x and self.y. And we forgot to require love, but yet again it's optional. So local love is equal to require love. There we go. Nice. We'll add this later, but for right now, let's just see how everything looks if we put it on the screen. Alright, so let's go to player, because here is where we'll be adding the lasers. We can go to the top and add a new item. We can call it lasers, and that will just be a table that's empty, because we can have multiple lasers. So we'll just have a table that can hold all of the lasers for us. We can then scroll down, and maybe right above the draw, we can add a shoot laser function. This function will allow us to shoot a laser, and that's it. This could be inside of lasers or inside of game or whatnot, but I feel putting it inside of player makes the most sense, because if you say player and then colon shoot laser, it makes so much sense. But if you say just laser shoot laser, it's kind of weird. So if you say player shoot laser, then you know the player is shooting a laser. And if you add an enemy, like maybe a spaceship, and the spaceship can shoot lasers, then yet again you can just say spaceship or enemy colon shoot laser. You can follow the same structure and it would always make sense. Cool. Now, for now, let's just go shoot laser, and that can be a function that takes in self. And here we can just go table.insert self.laser and then create a laser object, and we need to import laser. So you can say local laser is equal to require and then objects laser. Now I don't know if this dot syntax works, but if it works, let's use it. But if it doesn't work, you can use a slash. I'm going to try this dot syntax because my IDE constantly autocompletes it like that for me, so let's see if it works. Now down here, where we do this, we can go laser, and then it needs the x-axis, and the x-axis will basically be the same as our player, but we'll tweak this a little bit just to get it right. Let's just go self.x, and we'll tweak it so it's found like this. Self.y, self.angle. Cool. We'll tweak it more later because this won't necessarily work that great yet. But I just want to get it on screen. Now if we go to main, we can go maybe right here to where it says this key release, and we can say, or actually let's leave that for now. Let's go here first. And we have a few things we might want to do to shoot. So there's a few things the user can press if they want to shoot. First, I think space is a good item to press. Then as well as down, like the down arrow key. And then KP5, like that is the 5 on the numpad. I think that's also a good one. And in here we could just say player shoot laser, and this will shoot the laser. Now I also want the laser to be shot if a mouse is pressed. So let's say if the right mouse button is clicked, we want the laser to be shot. So if they want to play with their mouse, they can. So let's actually do that. So we can say function love.mousePressed, and this takes in quite a few things. So first it is X, it is Y, it is the button that has been pressed, is touch, for example if it's a touch screen, and presses, which is also for if it's a touch screen. I believe this X and Y is mainly for the X and Y position on screen. So let's say I click here, then that would be like 50-50 XY. Now here, you can say if button is equal to 1, and this is their left mouse button, I think. Then we can say if game.state.running, so only if it's the running state, player colon shoot laser, and I will shoot the laser. Cool. But currently if we're trying to shoot the laser, we won't see anything because we are not drawing it. So let's go to player and let's put the draw also here. So every object can basically contain its own version of the laser. So if you have multiple lasers on the screen, then every object will handle their own laser. So let's go here to draw. Let's just do it at the very bottom. So 4, and we can just say underscore because we don't need the key. laser in pair self dot lasers, and we can just say laser colon draw and then faded. And this faded is basically what's being passed in here. It's like that. Let's see if this works. Okay, space, and there we go. Currently they didn't move because we haven't put anything there. But now we can create a bunch of cool little lasers. And we can not use our mouse button. And the reason for that would be, let's see. That should be state. Like that. Now we can use our mouse button as well. Cool. So these are our lasers. As you can see, they're just little dots on the screen. They are only little dots because if we go to lasers, we're using points. If we were to increase this to, let's say, 30, then it will be massive dots, as you can see. So it depends on how big you want your lasers to be. Some people would like them to be really small, although then it's kind of difficult to see them. Oh gosh, where's my player? There we go. As you can see, it's very difficult to see them. So I think 3 is about a good size, but you could go up to something like 5 or even higher depending on what your preference is. But 5 is a little big. For me, personally, I'm going to go 3 because that just looks perfect. Cool. So let's implement the rest of the things into our laser class. So next up, we'd want to move the laser. So we can go move is equal to a function. This function just takes in self. Now, just like with the player, we need velocities, x and y velocities. So we can go here and we can say xvel for x velocity is equal to the laser speed times math.cos, pass in the angle, that's the angle we got here, so the same angle as the player, divided by, and then love.timer.getFPS. Yet again, it would be better to rather put something like dt here, just because it would be safer. But I don't think it's that necessary for a game this small. But if you plan on making this game much bigger, then you could definitely implement dt here. Next, we can do the same for the y velocity. But this time, instead of sin, or cos, we can go sin, like that. Now we have the x and y velocities. We also at some point probably want to remove the laser from the screen. And how we determine that is based on whatever you want. You can base it on time, for example. If it's been on the screen for 5 seconds, remove it. Or something like that. I, however, am going to determine that based on the distance it has traveled. So let's say it can only go 1.5 way around the screen or around the window. Something like that. So we can just say distance for the distance traveled, and we can make that equal to 0. Cool. Now we can continue to this move function here. And we can say self.x is equal to self.x plus self.x velocity. We say x velocity because remember, that's how fast it moves on the x-axis. Cool. And then we do the same for y. Nice. Now we want to keep this on screen. So we can actually just go here and we can copy this. You could possibly make this a function and you just reuse the function constantly because we're copying and pasting this the whole time. So it would actually be better to create a function and put this in. But that can be your homework if you want to walk the extra mile. Now for this right here, we don't have a radius because remember, we're just a dot on the screen. We are no longer a circle. We're just a dot. So here with the self.radius, we can just remove that. So like that, delete. Now it should be self.x less than 0. We set x to the width. if it's, and your southern radius with a minus, so let's just also remove all of those. There we go. If it's more than the width, then we want to set it to 0 and not the radius, because we don't have a radius. So we're going to set it to 0 because remember 0 would be this point right here where the window starts. Same here, the y0 would be this point right here where the window starts on the top. Next up, we want to say how far it has traveled. So the distance it has traveled. So self.distance is equal to self.distance plus math.square root. And here first we could say self.x velocity to the power of 2 plus self.y velocity to the power of 2. And this will just get us the distance it has traveled from point A to point B. This little part here. Cool. You could use some different math if you want to, but this works perfectly fine. Nice. Now we have the laser and the laser can move. Now let's move the laser. So I'm going to do that right here inside of this player. So right at the bottom. And we can just move the laser from here. So for index laser in self dot lasers, we can then say laser colon move, and this will move the laser. Now if we were to run this, the laser should move. Oh gosh, it's moving, but it's shooting in the wrong direction. Okay, so we did some wrong math, but now the lasers, they do shoot. So let's just go back to lasers and see what we got wrong. Oh, and right here, this should be negative because it's going to move in a slightly different manner. Now it should go out of, yes, now it goes out of the top. Cool. Now that is fixed, we can have a ton of lasers on the screen. I think that's actually pretty cool. Now, never do you really want this many lasers on the screen. You want to limit it. So we have to basically tell the lasers to destroy themselves once they're completed with all of this, once they're done. So let's go here to the player and implement that. So let's go to the top and we can specify the amount of distance the lasers are allowed to travel. So we can say local laser distance. You can also call this max laser distance if you want. And I'll make that equal to 0.6. So they can basically move 0.6 the width of the window before they get destroyed. So they can't go the whole width, but they can go 0.6 of it. You can change this to make it them travel further or less, depending on what you prefer. We can also then specify the max amount of lasers on the screen, and that can be 10. You could make it more or less depending on how difficult you want the game to be. When you implement maybe levels, you could make that, let's say on the most difficult level, you can only have like 3 lasers on the screen at once. Cool. Now we need to implement something that will destroy the lasers. So I'm going to copy this right here, and instead of shoot, it will be destroy. And this is very basic. We can just say table.remove, and we can say from self.lasers, and then the index. So now here we can also just take in the index. So it will remove the laser at that index inside of the table. Now where we move the laser, so down here, there we go. Here where the laser moves, we can say if, and I'm just going to do this inside of some brackets, but you don't have to. I just feel more comfortable if I do that. Love.distance, love, that should be laser.distance. If that is more than the max laser distance times love.graphics.getWidth, and let me just fix this. So if the laser has traveled 0.6 of the screen width. So that's what we're doing here. So 0.6 of this screen width. If it's more than that, then we want to remove it. We can then go here and say self.destroy laser. Let's pass in self and index. The index that we're getting here. So this will be the index where this laser can be found, which we're using here to destroy it. Right there. Now if we run this, then as you can see, the laser gets destroyed. If the laser moves too fast, you can make it slower. If it's too slow, you can make it faster. We can only have up until 10 lasers on the screen. But we haven't really implemented the whole 10 lasers thing just yet, because we can definitely shoot more than 10 if I had to guess. I'm not going to count that, but let's make it 3 so we can actually see the difference. Now if we were to run this, as you can see, there's definitely more than 3. So what we can do is we go to shoot laser and we limit it. So if the numbers in self.laser, so if the amount of lasers is less or equal to max lasers, then only do we want to do this whole insert thing. Otherwise, just ignore it. Don't allow us to insert another laser. So if we go here, my bad, and we run it, here we currently only are able to do 4 because this is less or equal to. So we could make it less instead, and now it will be more accurate. As you can see, only 3 at a time. Now if we were to change this here to, let's say, 10, then boom, Bob's your uncle, we can only shoot 10 lasers at a time. We're limited now. So you can see there's like a little wait period once I've reached that amount. So you can tweak that to make the game more challenging or easier depending on what you prefer. Cool. Now the one last thing is let's make sure all our buttons can shoot the laser. Okay, cool. So down works, space works, the button number 5 on the numpad works, and the mouse works. Okay, so if all the buttons work, that means we have done our job correctly. We have now implemented shooting lasers in the game. In this tutorial, we'll be adding collision for those lasers, and it will be pretty cool. Now I have to show you this. Let's just move this here. If we go here and we shoot, it splits into 2. Shoot again, it splits again. And shoot it again, now it's gone. And this is a very customizable thing that have popped up here. So you can make this more customizable and maybe break up into more pieces, maybe move faster, maybe be bigger or smaller. And once you shoot it up, nothing happens, but we can implement that later. Isn't that incredibly cool? Also something you might notice, if we were to go here and we were to shoot, pew, you'll notice it's a little explosion animation thing where it has a little bit of color once it touches the asteroid. Nice. Now I'm going to remove the whole debugging thing, not from the game, but just from our visual standpoint, because currently I don't think we need it. But if you do get stuck and some sort of error occurs, turn on debugging and see what's happening, because especially when we do collision detection, which our debugging is exactly doing, showing us where the collision happens, then that is when it's most important. But I'm going to disable it, but I'm going to make sure that we can re-enable it easily again later. Cool. So let's create a new file. Just say new file, and this can be globals.lua. Now these are going to be variables that are going to be global scope, like massive global scope. Everywhere this can be used, and that's the point of this file. So whatever we put in here, we can use anywhere within the game. So let's first do asteroid size, and let's make that 100. We'll be using this asteroid size in multiple files, so it makes sense to put it here, because we're not going to attach this specifically to an object. this will just kind of be there. It will be able to be used whether that file uses the asteroid object or not. And then you want to have show debugging. You can make this all capital case just like with this asteroid size. But the difference is we don't want to change this asteroid size in the game. It's a constant. We don't want to touch this except if we're getting the value. But we don't want to set a new value. We don't want to change that to 150 while the player is playing the game. We could, but we don't want to. Show debugging, however, we might want the player to allow them to show debugging. So like if they go into the settings, they can turn debugging on or off if they're maybe a developer or is interested in that sort of thing. And we can make that equal to false by default, but you can keep it true if you still want the debugging information. Now, one last thing I would like to do is do our distance calculation math here. And this will just calculate the distance between point A and point B. We can say function calculate distance x1, x2. So this can be y1 as well. We can do x1, y1, x2, x2, or y2. Now, this will be the x and y position of the first item. Then we want the x2 and the y2. So this will be x and y position of the second item we're trying to get the distance from. You could put this in their own little tables instead, but I think that's overkill. So let's just do it like this. We can then return just a simple math function, so math.square root, so squirt, and then first we can go here and say x2 minus x1, and then to the power of 2. You could split this up into multiple lines. Don't get me wrong, you could split this up into multiple lines. And why not? Let's actually show you how it will look. So go here and say local dist x, and then we can go here and we can move that like that. And then here we can go local dist y for the y distance difference, and it will be the same thing, but this time it will have y instead of x like this. So remember, it's the second y minus the first y. So it's where you are going to minus where you are. That's very important to take note of. And then in here, we can just say dist x plus dist y. And this will give us the distance between x and y. So this math right here. Not between x and y, but the distance between those two values. x1 and y1 and x2 and y2. Yeah. Alright, and that is the basics for this right here. So that is how we calculate the distance between x and y of two items. And now we can close that because we don't need it anymore. And also it seems like this dot notation works. Since my IDE auto-completes that, I'm just going to leave it like that. So you can just use this instead of slash from now on. But in the game code that I'm going to provide you, if you ever download the code, it's going to use slash and not dot. Cool, so let's remove the debugging stuff from our objects and stuff. So let's go here and to the player. And here where we take in debugging, we're not taking that in anymore. It's now global scope. And it's called show debugging instead of debugging. So debugging right here. So instead of debugging, we can say show debugging because it's global scope. And you don't have to, because Lua will automatically know. But I would recommend you go require global like that, because right there, so you want to require that. This isn't required to do this is an optional step, but I do recommend if you're going to use global stuff here. Then you can close player. Now here in main, where we pass in show debugging, we can remove that. And we can actually remove this debugging as well. Now let's first go to the laser, because that's where a lot of the things are going to happen. We're going to add a few new things. We're going to make them like states. So first will be the exploding state. And this can have 3 values. It can have a 0 for safe, a 1 for exploding, so if it's currently exploding, and then a 2 for it's done exploding. And then also an explode time, and this will hold how long it has been exploding. So if you want it to be on the screen for like 1 second, then this will allow you to keep it on the screen for 1 second. Cool. Now let's go to move right here, and let's first check if it's exploding. So if self.explode time, if that is more than 0, then we know we are exploding, because otherwise it will always be 0. But if it's more than 0, that means we're currently busy exploding. So self.exploding is equal to 1. What I actually recommend you do is you set some sort of state to help you with this. For example, local exploding enum or something like that. And it will be a table that is like not exploding, and it will keep 0. And then exploding, and that will keep 1. And then I think there was the last one for if it's done exploding, like done exploding. That's equal to 2. I'd actually recommend you do this instead, just to keep things simple for you and for your future self. Because if you're going to continue working on this, then having something to manage it is the smartest idea you can have. However, once this course is done, I'm done with this project as well. So I'm not going to add it. To me, it's not necessary. While we're here, let's set the explode duration. Explode duration. And I'll just set this to 0.2. You can change this later depending on what you think is the better time to explode. So the more you make it, the longer it will be exploding. Now we need to implement a function that once we want to explode, we can. So we can go here and say explode is equal to a function and just takes in self. And this will just explode, in quotation marks, our laser. Now we're not going to mess with the explode time just yet. Currently we just want to remove everything. But for right now we can say if self.explode time is more than explode duration, then end self.exploding is equal to 2. And this will just make it explode. And it will kind of allow us later to do some exploding animations. Next up, let's maybe go to Asteroids. So we can go here, we can open up Asteroids, and we can implement our stuff. First, let's take out debugging. We don't need that anymore. And now we should have something that wants to debug but can't. There we go. And we can change this to show debugging, and we can require globals like that. And boom. Now that that has also been done, we can now go to game.lua. And here it goes to Asteroid and it adds this. We don't need that extra one anymore because that was just for debugging. Debugging is now global. If you turn debugging off, everything will have debugging turned off. If you turn it on, everything will have it on. You don't have to individually go change which one has debugging and not. So now let's go to the player.lua and we can go to the way bottom where we are at. So right here we're getting the index and the laser. And now we want to check if the laser is exploding. So for right now, none of this really matters. We can just go if laser.exploding. So if the laser is exploding, and we're going to make sure if it's 2, then we can just say self.destroy laser. And this destroy laser, if you can remember from the previous video, it just destroys the laser. It's very simple. This is going to become a bit more complex in a second, but I just want to get the idea out. Next, we can go to lasers. And when we go to explode, we can just make it disappear. So we can just actually, for right now, remove that. We don't need that. We can just set the exploding to 2. Now, once it explodes, it's going to set the exploding to 2. So we should also go here and say if if laser dot distance, so it's the distance it has traveled, if it is more than the max laser distance, so actually this right here, so let's actually just go here instead, and let's just go and add and, because it already has the first part. So if it has traveled the distance of the max it can, and the laser dot exploding is equal to 0, So only if it's not currently busy exploding, then we can explode the laser. So we can just go here and change this to explode. And it's going to now be laser explode. And it doesn't need anything. This destroy laser, however, needs self and index. So we will now actually see if it works. We'll move this explode up. So if it works, it should disappear once we run it. So it's gone. Okay, so it does work. We can now just make it work better because, as you can see, they do disappear. Alright, now that we know it works and it disappears, let's upgrade what we have. So with this explode, we can then say self.explode time is equal to math.seal to make it go upwards, explode duration times, and here we can just say love.graphics.getFPS, and there should be timer.getFPS. Yet again, I would recommend we actually use DT, but in this scenario, it's not too important. And we can divide it by 100. And this will basically say how long it has been exploding for. Then we can go here and say if self.explode time is more than explode duration, we can just put that there, and exploding is equal to 2 then. Now, as we know, if the explode time is more than 0, so if explode time is more than 0, it will set exploding to 1 for us. And then it will be busy exploding. And we can draw things here like it is busy exploding. Like some nice things. Now the nice things I do want to draw is maybe like a yellow and an orange explosion animation type of thing. And it will just appear once it's busy exploding. So let's go here where we draw everything. And we can just say if self.exploding is less than 1. So if it's not 1 or 2, if it's 0, then we can just do this, what we've been doing this whole time. Otherwise, if it is busy exploding, we can go else, then we can say love.graphics.setColor, and this will be of the outer explosion, so the bigger explosion. And we can just say 1 for complete red, then 104 divided by 255, and then no blue. And you can also pass in the opacity in case they're pausing. And then we can set the color for the inner explosion, so the smaller explosion inside. To give an example of what I'm talking about, let me just go here. If I shoot, as you can see, it's paused, but as you can see, there's like a little orange part, and then inside of it, there's a yellow part. And that's what we're currently doing. We first did the orange part, we're now going to do the yellow part. And let's actually just copy this love.color. And yellow would be a bit more greenish, so 2, 3, 4. And actually gives it like a yellowish color. We're going to go here and say love.graphics, and we can draw a circle. Circle, and you could of course make this way more complex and cooler, but I think this is fine for now. Fill, and then self.x to give the x position of the laser, and then self.y to give the y position of the laser, and then we want to make it a special size. We can first just make it a 7, that's not very big, but the bigger one, and we can just go times 1. The bigger one, however, will be times 1.5. So it will be a teeny weeny bit bigger. So around 10, whilst this one here, this one will just be 7. You can even remove that if you want and just have a 7 there. But this would be 7 and this would be almost 10, maybe 10. But yeah, you could make this more like 2, and you could put this in a variable to make it a set size and you just add to it. But yeah, it's up to you. You can change this so it's not math, it's just a number that you put in there. It's up to you. Now let's go look here. If we run this, then at 62 instead of our laser, we have a problem. So right here, and this should not be and, this should be times, my bad. And now if we run it, we should not be getting any errors. Cool. It's not going to quite explode as we want just yet, because if it doesn't hit anything, we don't really want that explosion animation to happen. It should just disappear. Otherwise, it would be kind of weird if it just randomly flew and then boom, it exploded. Then that would be a bit weird. Cool, let's go to player. So first, this laser move, we don't always want to move the laser. If it's busy exploding, the laser should just stop moving. Otherwise, it's just going to hit an asteroid and keep on moving, which is a bit weird, but could be cool if that's what you want. So we are already doing the whole explode thing here. So let's go here to where we say exploding is equal to 2, and let's add another if statement above it. And this one can be if it's 1. I mean, not 2, but if it's 0. So if it's 0, then we just want to move, because then it's not currently exploding. So we can just go like this. But yet again, we sit with the problem. It can move and it can explode on the same time. So we can just go here and say else if. So it's either this one, else this one. But if it's not 0 or 2, it's not going to do either of these. So if it's 1, it's just going to stand still, and it's not going to remove the laser from the screen. Because here it removes the laser from the screen, and here it moves the laser. But if it's 1, it's busy exploding and showing us that orange and yellow, so we don't want to then move it or destroy the laser just yet. Alright, now let's go to main, and here maybe an update. I'm just going to hide this. We can now go and go 4, and we don't need the index, we just need the laser, and we can just say player.lasers, and here we go laser colon, or we don't need to explode just yet. First we need to calculate the distance. So if, and then we can just calculate distance, which is coming from that global file, so require globals, so that's require distance, and then go laser.x, laser.y, so this is the first one, this is where we are, and then we need to go, or then we need to add where we're going, so the asteroid, asteroid.x and the asteroid.y, and this will calculate the distance between the two. If it is less than the asteroid.radius, so if this right here is less than this radius of the asteroid, so if it has entered the radius of the asteroid basically, then we want to laser colon explode, so then we want to explode the laser. Let's see if that works. And that's going off screen, and there we go. Pew. And it is, although it's not doing much, it is there. So we give it a shot again, as you can see. Now if it enters, or almost enters, depending on how the circle is positioned, then there we go. Now if we were to turn on debugging here, so if we were to open up globals again, and we were to make debugging true, we could see where the laser will explode. So the red circle is where it will explode. So it won't necessarily explode on this part right there. It will explode once it hits the red circle. Cool. Now once we do this, we need to also destroy the asteroid. So let's go here to asteroids, and we can add another function right underneath move. You can also call this explode. I'm going to call it destroy, because you're destroying the asteroid, but it's not necessarily exploding. So destroy is equal to a function, and this takes in self the asteroid table. So this asteroids table will be provided to us. It is to basically get the asteroid we want to destroy. You could put this somewhere else, so you don't have to make it part of the asteroids. In fact, it would make sense if you don't make it part of the asteroids, but it would also make sense if you do. It's up to you if you make it part of the asteroids or not. But then we also want the index of the one we want to destroy, and then we want to take in the game as well, so the game state. And I'll show you why we'll need all of this in a second. First, let's just remove it. So table.remove, and then from the asteroids table, the index. So these two we're passing in. So let's quickly remove game for now. Now, if we have this, we can then go here. Let's include game. It's not that big of a deal adding it here. Then here we can say asteroid colon destroy, because if it's here, then that means the laser has penetrated the asteroid, so we need to destroy it. And we can say asteroids, then the ast index that we're getting here. So this is the table and this is the index. And then we can just pass in game as well. Game, which is right here. If we save this, then the asteroid should also be destroyed once we hit it. As you can see, it's gone. We'll do it again. And then my player is gone. Very annoying bug. I go here, shoot, gone. Now we want to split the asteroid up into multiple smaller asteroids. So let's go here to asteroids, and where we say destroy, we can then go local min asteroid size, and this will be the minimum size an asteroid can get. And you say math dot seal, and you could put this right here, you could put it like up here. That will also be perfectly fine. I'm just going to do it here because why not? And we can say asteroid size, so the current asteroid size we have, divided by 8. You can change this to fit you however you think would be best. Then if self.radius, if it's more than min asteroid size, then we want to basically split the asteroid in half. So table dot insert asteroids table, so into this table right here, an asteroid object with the position of self.x, so the current asteroid x position, self.y, self.radius, and then the game.level. We can just go here and say self.radius. If we go up here to draw, or not draw, but here, we're taking in x, y, the size, and then the level. And then here we could make another one, and now we have 2 new asteroids. Now if you wanted to, you could make this go, you can go another step and add another asteroid, but only once one of these asteroids has been destroyed. So then it splits up into 3 smaller asteroids. So once the second smallest asteroid has been destroyed, you split it up into 3. So the big asteroid, that splits into 2, which are smaller asteroids. And then this will also split into 2, but you could make it split into 3 if you're not too lazy. However, I'm going to leave it as is because I'm fine with it as is. If we run the game and we shoot, there we go. Now it's split into 2. There we go. Now that's also split into 2, but you could make it split into 3 if you think that's better, and it will be more challenging. We go here, we shoot. Now there's 2, and then you can destroy the rest. And then here we go, and the pew 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 pew, gone. And yeah, that is the basics of adding collision detection to our game. Now we're not going to implement quite everything just yet. We're going to implement the basics of destroying the player. But a lot of the things that we're going to also implement will come later along with different parts of this tutorial. So things will maybe be coded out for the future's sake, whilst other things will just be left for later. But yeah, so to give an example of what we'll be doing, we go here, we fly, boom, there we go. So first, let's open up the globals. I want to add another item here. So destroy ast for asteroid. Now, you could put this inside of the asteroids object, and I would encourage you to do if you want to. However, this global object will make it a lot easier to manage this in the future, since we will be using this destroy asteroid in multiple files. Cool. Next up, we can open up the player. And it will be a lot like our laser course with collision, but this won't just be for the player. So a lot of the things will stay the same, but just a bit modified for the player. For example, local explode for explode duration, and that would be 3. So this is how long in seconds, and in this scenario 3 seconds. Then we can go here and we can say explode time, so how long it has been exploding for, so we'll make that 0. Exploding, so if it's currently exploding, we can make that false. And unlike with the lasers, we don't need a third item in exploding. It can just be either it's exploding or it's not exploding. We don't need a third one. Since usually what will happen is, if it has finished exploding, unlike with the laser where it just disappears and you can just shoot another laser, here if the player has exploded, then once the explosion finishes, we'll start a new game. Or not a new game, but just we'll put the player back and we'll respawn the player basically. And we'll do that in a future tutorial. Cool. Now first thing we can do is we can close this, we can close this, and we can draw the player exploding. So right here before the thrusting, because we don't want to thrust or move or things like that if the player is exploding. So we can say if not self.exploding. So if it's not currently exploding, then we want to do all of this. And here we can just say we can just say end for now. It's fine. And we can indent this. So if the player is not currently busy exploding, allow the player to thrust forward and to move around and whatnot. However, if the player is exploding, then do something else. So draw something else. And this will be very similar to our laser, what we have drawn here. So this right here. So we can actually copy that. It will just be modified a bit. And we can paste it here. So first, we want the largest circle to be just pure red, just to give it more intensity, because the ship itself is much larger and much more complex than a laser. So we want the ship's explosion to also look like it means more, because it does mean more than the laser. The laser explosion disappears faster and it only has like 2 colors and it's very small. Here we want it to be rather large and to have more than 2 colors to show, hey, this is some big thing that exploded here. This can stay the same. However, this time we can use self.radius instead, because we now have a radius to work with instead of just a dot. Same here, we can say self.radius and then just ×1, or we can remove it and it doesn't have to say ×1 at all. Then here we can say 158 to give it a nice little color here. And then if we were to copy this, paste it here, and in here we can say 234. This will be the smallest one and it will be 0.5. So you can see how they scale in size now that we use times, and now you'll understand why we use times, to help it scale without us having to do much. And this is how it will look once it explodes. We'll take a look on how that looks in a second. Currently, let's actually just allow the player to explode. So let's go to the move player section. I'm just going to hide this draw. Then the move player section, this whole part here, we can just say if not self.exploding, so if the player is not currently exploding, then we can do everything and then paste that in there. And we can just indent, and there we go. So if the player is exploding. Now you can set if the player is exploding by going self.exploding is equal to self.explode time. Could you please autocomplete? There we go. If that is more than 0. So this will return true or false. So if the explode time is more than 0, then the player is exploding. Cool. So this will only execute if it's not exploding. However, take note that we don't want to actually stop the lasers. So this whole section here for the lasers, we can move that to underneath the end of this if statement. So this one right here, it does not hold the lasers. The lasers can still move and stuff. If the player explodes, the player explodes. But the lasers are not affected by it. We can then save. And then finally, we can implement an explode function. So that's a function, takes in self. And now we can just say self.explode time is equal to math.ceil. We can then specify explode duration times love.timer.getFPS. There we go. So this will explode the player for us. We can then go here to globals. Not globals, my bad. We can then go here to the main file. And here where we have an update, we can go to when it's running. So right here when it's running. Then we have our move player first. Then we do our asteroid stuff. Then here in the asteroid stuff, we can go if the player is not exploding. So player.exploding. So if the player is not exploding, we can copy this line of code for the laser like that. We can paste it here. And this will allow us to check if the player has collided. However, we don't need this for loop. So we can just remove that, unindent. You have a calculate distance, but this time instead of the laser, it's the player. So the player X, player Y, and then player explode. And in here, we also want to go, and then instead of saying asteroid destroy, you want to say asteroid or destroy asteroid is equal to true. And this is in our globals file, destroy asteroid. If this is true, we want to destroy the asteroid. However, we don't need to set that here. We're only setting it here if the player specifically explodes into an asteroid. And you will understand more about why I did this in the future, or why we are doing this. Then here we can say else, so if the player is exploding, then player.explode time is equal to player.explode, oh gosh, I can't type. Player.explode time -1, so it will decrease if the player is exploding. Then after this for loop, we can go if. So if we want to destroy the asteroid, then you want to set destroy asteroid to false again, because we're destroying the asteroid. And then we can go asteroid :destroy. And we can just actually copy this whole asteroid destroy thing, because it's the same code. Now, one reason why we are doing this right here and not this here as well is because here there are multiple lasers that's going to try and destroy the asteroid. So if two lasers collide with different asteroids at the same time, we're going to have a problem, because what is it going to do? Destroy asteroids is true. So what? If you understand what I mean here, because if two lasers collide against two separate asteroids, but destroy asteroid is true, it's just going to be incredibly confusing. Anyhow, then there we have our ast index and we have our game, and then here we can move the asteroids. Now let's run the game and see if we explode. Boom, and yep, the rest of the asteroids are moving. However, if we go and we fly against an asteroid, we can still see our player. We don't want that. We don't want to see our player. So we should go here to player, and we should make sure we got the if-else statements correctly. So if not exploding, then everything is just held in. I mean, this is for the moving, it's not for the drawing. Okay, let's go to draw. Now, let's see here. If not exploding, then we can do everything in here. However, if the ship has exploded, then let's see here what's happening. Alright, I see. So here we already have a bunch of things, but this is only for the thruster. We need to include everything as well. I kind of missed all of this. So let's just go like this. And we can just cut. And we can go here. And we can just say paste. So now we'll not only just not draw the thrusters, but we'll not draw anything else. while we are exploding. So if we go like this, and now if we were to try and hit an asteroid, we can't see our player anymore. And there we go. We've implemented collision detection for the player. And hello everyone, if you're enjoying this tutorial, please leave a like and subscribe for future tutorials. In this tutorial, we'll be adding lives to the player. So once the player explodes, instead of the game just ending, they have a few more lives they can spend before the game is completely over. So let's get started with that. First, I want to give you an example of what we currently have. So if we were to go here and say Love2D, this is what we currently have. There goes our asteroid off screen, so it should appear right about there somewhere. Yeah, and boom. We explode, and we just kind of continue. Just very boring. However, when we explode, that shouldn't happen. Or when we hit something, that shouldn't happen. In fact, this should happen. So this is an example of what we'll be doing. So as you can see at the top, our player lives are there. When we hit an asteroid, the player lives, they go red, they disappear, and we start in the middle of the screen again. And we can use up all our player lives until we are no longer there. Once we are no longer here, then game ends. The last asteroid does not explode once we hit it. That is to prevent a bug. But you don't have to worry about that bug because I'm fixing it here for you anyways. But let's get started. So, first we want to now take in the num lives. So how many lives the player should have. Then down here we can just say lives is equal to num lives, or by default it can be free. So if you don't pass in a number of lives, it will be free by default. Next up, let's draw the player lives. So maybe right here underneath draw, we can say draw lives. This is a function that takes in self and faded. Cool. We can copy a lot of things from this player draw. So if you do not mind, I am going to copy basically everything from here because a lot of this code is copy paste from what we already do in draw. Because first we set the opacity. Depending on if it's faded, the opacity will change. And in here is where it fades a little bit from what we do usually against what we want to do. But we'll still keep a lot of this. For example, this right here. We want to keep this. So let me just delete this part here and this laser part as well. We can keep this polygon and this color. We can remove the debugging because we won't be doing debugging on it. And we can also remove all of this. And now we have a bunch of the code already given to us because we have already coded a lot of this. Nice, let's just indent this to there. That's much better. Now, first we want to say what color our lives should be. Because if we go back to this example I have, and I can just move it over. Now as you'll see, if we have 3 lives, then it's white, the same color as the ship. If we hit an asteroid, then it becomes yellow. And if we hit an asteroid again, where we only have 1 life left, if I don't miss the asteroid, which I did again, my aim is terrible. And now it will be red, because, hey, you should watch out, buddy, you only have 1 life left. And that's what we want to do here. So we want to set the color depending on the amount of lives the player has. So first we can say if self.lives is equal to 2. So if they have 2 lives, then we can copy this right here, paste it there, and we'll modify it in a second. Then we can say else, and this will also contain an if and an else. So we can go like this. And then we can just copy this and paste it here. And we can remove this. Now, if they only have 2 lives left, we want to make it 1, 1, and then 0.5. And this will make it a kind of a yellowish color. If they have 1 life left, then we want to make it red. But not completely red, just a little red. So it will be red, and then 0.2 green and 0.2 blue. And in here, if they have 3 lives, so if they have 3 or more lives in this scenario, because this is 2 and then 1, if you want to add like 5 lives, you can maybe add more colors, or you can just make them all white until it hits 2 and then it will change color. Anyhow, if they have 1, it will be red, and if they don't have 2 or 1, if they have 3, it will be white. Then the draw lives, we need basically to get the X and Y positions, or to give it a default X and Y position. You can make this like a more globally state one, like put it here or even put it here. It doesn't really matter too much. In this scenario, I just want it here at the top of the screen. So I'm going to do an easy local X pos Y pos is equal to 45 and 30. So X would be 45 and Y would be 30. So 45 from the side, 30 from the top. Then we can create a for loop. So for I in 1 to self dot lives, so the amount of lives we have. And we want to basically draw 3 lives. So we can just plop that in there because the lives are the same shape as the spaceship. And we can go if we are exploding. So if self dot exploding, then if I is equal to self dot lives, so the amount of lives we have. So we don't want this to happen if we have less lives on the screen than what we currently have, or more, you know. Then you want to basically make the heart completely red. So love.graphics.set color, and then 1 0 0. So basically, once we explode, then it should change the color of the spaceship to pure red until the explosion is over, in which case it will switch to whichever colors are here. Cool. Then down here, since we can't just draw the spaceship on the same position or at the same position everywhere, we need to specify a few things here to make the lives go on different locations. Because if we don't, then the lives here, they won't be 3 lives. Like I wish I could show my cursor here, but there won't be like 3 lives there. There will only be 1 and 2 others on top of it. So we need to specify where to position it. So instead of self.x here, we can go and say I, so the current index we are on, or the current position, times x position. And this will give it its wanted x position. And then as for the self.y, since the y will never change unless you make it go in a x direction instead of or in a y direction instead of an x direction, then the y will never change. So y pos. But if you wanted to, you could make the hearts go from top to bottom instead of from left to right. It depends on what you want. Personally, I think going from left to right is perfectly fine. But once you have done that, then boom, we are basically ready to go. Now, we also need to remember that we don't want these to change angle with the spaceship. You could, there's nothing wrong with it. It's just if you make it change angle with the spaceship, then that it could kind of make the player a little bit confused about, like, while he's playing and suddenly he sees the spaceship hearts moving as well. It could be cool, but it could be very distracting. Personally, I think it's too distracting and I'm going to remove it, but you don't have to if you think it's a cool feature. Instead, we can go here, select all of these, and remember this view angle we created here at the top? That is the default angle our spaceship is always at. So we can just specify view angle instead. So now it will always face 90 degrees and never change. But if you want it to change, then you can 100% do that. I just don't care to make it change. Cool. Next, before we continue, I would like to go to globals and make sure this is here. Just to make sure that is there. So if you forgot about this, just put it there. Nice. So next up, we can just go to the main file And let's draw our lives. So let's go here and we can say player colon draw lives. And if the game is paused, so game.state.paused. Because if the game is paused, we want it to be faded. And here we go. That shouldn't be an and symbol. My bad. That should be a times. Okay, now let's try it. There we go. So now our lives are right up here, as you can see. So that's nice. Currently, if we hit an asteroid, nothing's going to happen. We're just going to kind of die and then respawn and then hit them again and again and again. We don't want that to happen anymore because we now have lives. We want the player lives to decrease and the player to restart from where he was or she was. So let's go to the top and let's see. And this is not the right file. We go to menu and here where it says explode time and then what the explode time does. We can go and say if player.explode time, if that is equal to 0, then we want to go if player.lives -1 is less than 0, meaning if the player doesn't have any lives left, then game colon change game state to ended, because if the player's amount of lives -1 is less than 0, meaning they have like -1 lives left, then end the game. And we should make this less or equal to, because yeah, just because. But you could make it less than 1 if you wanted to, because let's say the player has 1 life left. Now they hit an asteroid. Now 1 minus, or now the player lives, changes to 0, and 0 minus 1, that is -1, and that's less than 0. So in return, it should change the game state to ended, because if the player has 0 lives left, then we don't want the game to continue. And then we can just say return, because we don't want this to continue the loop, or to continue this loop. Nice. Otherwise, just always go player is equal to, and then a new player, and then the player dot lives -1. And there we go. So now the player will always have 1 less of a life once they hit this, or once they finish exploding. And I should save without formatting. Now if we run this, and let's see what happens when we hit this asteroid. We lose a life. And we start back at the screen. The reason we started back at the center is because we create a new player. And when we create a new player, the player by default is in the center of the screen, because that's what we hard coded here, in a sense. We basically said, hey, once we create a new player, put them in the center X and Y. And that's what's happening here. We're creating a new player and storing that player in the old player variable. So don't get too confused here. We're just creating a new player object, storing it in here, but it kind of has a lot of the old player stuff. By that, it just means the lives. So yeah, now if we hit an asteroid, we go, we lose a life. Now we have less lives. We hit another asteroid, we lose a life. Let's hit another asteroid here. And there we go. Now the game has changed to ended state. Okay, meaning it's basically over. Now, I still want to do a few more things before we continue. So here, if destroy ast, we can now go if, and then else. Now inside of the else, we can now put this. And then this if statement can check player.lives -1. If that is less or equal to 0, then we want to go if player.explode time, if that is equal to 0 as well. Then we want to set this here as well. So basically, if the player lives is less or equal to 0, basically the same check we did here. However, this check will not execute quite as quickly, because this one will execute after this check. So this check may be false, then this executes where this check could be true, but it executed after So see, this executed after just right here, so after the check. So player lives here could still be 2. Then we go here, and then player lives is 1. Because remember, code goes from up to down. So we're doing the same thing here, but now it's here at the bottom. And since it's going up to down, it will trigger this. And then we check if the explode time is equal to 0. Then just do everything as normal. However, if the explode time is not equal to 0, then just don't do anything at all. The reason for this is once we basically finish the game, once we basically get to the last asteroid and we hit that asteroid with our player, it can cause a few issues. And this will just fix a bug in the future. But you don't have to worry too much about this. Just put that there. We save our game, we run our game, and now we fly, we hit, we respawn. We wait for our targets to come back, we fly, we hit, we respawn. And now for the last one, we fly, we hit. It doesn't get destroyed immediately, and that is exactly what we want, because that could cause errors. Because let's say that's the very last asteroid before we go to the next level, and then it wants to go to the next level once we hit it. But once we hit it, we have our last life there, it's not going to be a good match. Because let's say we only have 1 life left, and there's only 1 asteroid left. Once we hit that asteroid and we lose our 1 life, it wants to go to the next level, and this is in the future once we implement levels. But if it wants to go to the next level, and we just lost our last life, that's going to cause a few errors. And so we say, if we hit against an asteroid with our last life, then it's game over. Then we don't get that point or anything like that. In this tutorial, we want to add a menu to our game. So to give an example of the menu we're going to create, we go here, we have our little player circle, we have a quit, we have a settings, and we have a new game. If you click on quit, it will quit the game. Settings will be your homework, so clicking on settings will not do anything. And then clicking on new game will start a new game. Then let's go here. And then once we reach our last life, it will give us a game over screen, but we have yet to implement that. But once we finish implementing that, then after the game over screen, it will take us back to the menu screen. And that is what we want to do. Okay, but this tutorial is going to be pretty long, so we won't be doing the ending screen just yet. So first, let's go here to the game.lua file, and let's go to the top, and here where it says state, I want to change all of the other states to false and the menu state to true. So by default, the menu state will be true, meaning once we basically start up the game, it will give us the menu state. Not currently, but it should give us the menu state. Cool. Next up, let's create a new component. So component, new file, and then button.lua. And this will be the buttons we want on the menu screen. Unfortunately, the menu screen is legitimately just buttons, so we have to do this before the menu screen. We can just say local love is equal to require love, and then local text, because we're going to need text to display the buttons, is equal to require components dot text or slash text, depending on if dot text doesn't work for you, you can go slash. Both of them work for me. We can now create a function and call it button. It will take in quite a few things, so we'll get to that, and then return button. So let's get everything already ready in here. Let's just say return, and then in there. Now a button will take a lot of things. First, once we click a button, we want to execute a specific function for that button. We don't want to implement that function inside of the button itself, because if we do that, then it could cause a little bit of a problem with us needing to basically, for every scenario code a function. So it's better to pass in a function and then to execute that function on button click. So we can say func for a function we want to take in. Also the text color of the button, the button color itself, the width of the button, the height of the button, the text on the button, where the text should be aligned to, so the text align, the font size, and I know this looks like a lot at the moment, but believe me, we'll go through all of them slowly. The button X position, the button Y position, the text on the button's X position, and then the text on the button's Y position. Cool. So now we have the basics of a button here. Now first, let's say local btn text for the button text is equal to an empty table, and we'll get back to this in the future. Then our function is equal to the function passed in. Or if there's no function passed in, we can then say or function, and we can just remove this end, or we can just not remove it, but just bring it to the end of this statement. So one-liner function, print, and we can just print this button has no function attached. So basically, if they save, or if they click the button and they didn't add a function to it, it will print out to the console, hey, there's no function attached to this button, you can't click it. Next up, I want to position the text of the button. Now, if you remember from the previous tutorial or from the previous game we made, where if I were to go here, as you see our buttons, they have a little space here. But if you could remember from the code we wrote for these buttons, is that the text in the button is positioned relative to the button itself. Meaning, if we position a button here, then and we say the text is 10 pixels to the right, then it's going to be inside of the button by default 10 pixels to the right. Meaning the text isn't going to be 10 pixels from the border of the screen. It's going to be 10 pixels from the border of the button. If you can't quite remember what we did here, I do recommend you maybe go back to the files and just go check on how we created that button. And maybe that will bring back some flashbacks. But it's not a big piece of code we have to write for that. So let's quickly do that. So if text Y, so if the Y position was provided, then btn and then text dot y will be equal to text underscore y plus button y. So plus the y position of the button, because it needs to be the amount we give it plus the button. Otherwise, we'll have to manually calculate, if you want it on the center of the button, where the center of the button would be relative to where we already have it. So we anyways have to do this later on if we want the text to be inside of the button. And you can still make the text outside of the button even with this method here. You just use minus or just a massive value, depending on what you want to do. Anyhow, let's continue because this is a big file. Then we can yet again just go like whoop, go like this, and then do this, but without this. Now you have a choice here, and let me just go back to my here. You have a choice. You can either do this if-else statement, or you can go here and say y is equal to, and then button y, and then you can remove this part here. This will work just as well. So it's up to you what you want to do. However, I'm going to use this else statement here. You can then copy this, and now you can do it for x. And in here you can just change this to x. And there we go. We have just as quickly added our x and y positions for the buttons, or for the text on the button. Now let's go here, and we can just say text color is equal to text color, or if they didn't specify text color, we can just make it white. So R is equal to 1, G is equal to 1, and B is equal to 1. Like that. And we can do the same for button color. So button color is equal to button color, or, and we can just copy this one here. However, the difference will be is that by default the button color should not be white because the text is already white. So if they don't enter the text or the button color, you want to make sure that the text is still visible since the button would now be black. You can swap these two if you want to, but yeah. And we can go the width of the button is equal to the width we enter or 100. And then the height of the button is equal to the height we enter or 100. The text is equal to text or, and you don't have to specify or with any of these. I'm just doing it for in case I want to leave something out, or in case you might want to leave something out in the future. The more customized this is, the more things you can later on leave out. Anyhow, and then no text added. So if no text was added, we can just put that there. Or you could force it, it depends on what you want. The text X position is equal to the text position passed in. And we're not using this text position here quite yet, but you will see in a second where we use that. Or we can make it the button X. Or if they didn't specify at all, we can just make it 0. We can do the same for the Y text position, where all the X's are just Y's. And we can go here and say the button X position is equal to the button X position or 0. And then the button Y position is equal to the button Y position or 0. Cool. And then finally, we need to use a text component that will put the text on the screen for us. And we already have a text component that's been imported right here. And every button will have its own text component. So we can just say text component is equal to text. And then we can just pass in all our values. So we can say text btn text.x. So here we use the button text. But here we specifically use the X and Y given to us. And we can of course do the same but for Y. And as you can see, also our documentation is here, which is very nice. And this is some documentation we did a while back. So here we go, and as you can see, we did a bunch of documentation. And now the documentation appears as I'm trying to edit this. So that's pretty neat. So now we know we need the font size, and the font size is passed in. And then also, whether we want it to fade in, which is false. We don't want it to fade in unless you want to add some animation. Fade out is also false. The width, and then the text align like that. And then finally for the opacity, we can just pass in 1. We don't want to change the opacity. However, if you have buttons in your game, you want to make this a dynamic value. So value passed in as a variable and not just one. So it depends on what you want to do. If there's buttons in your game and not just in the menu, so when they pause and you want it to fade out when you pause, then making this an actual variable would be better, because you can change the variable later. Let's draw the button, because I actually want to get the button on the screen. So draw is equal to function self, and we can just add in our comma. Then here we just say love.graphics.set color, so the color we want the button to be, and we can go self dot button color and then just specify red. And we can do that for all of the colors we have. So let's do that. And there we go. Now the color will be set to what we want the button color to be. Then we can draw a rectangle. So love.graphics.rectangle. And we can just say fill this rectangle. Or don't fill it. It depends on what you want. But I would like to fill it. Since it's a button, it makes sense to fill it. Self, then the button X. Self.button Y. Self.width. And then self.height. and this will draw the button for us. Next up, we need to do the same, but instead for the button, we need to do it for the text. And we also want to reset the color back to white. So here we can go here, but instead of button color, we now go text color. And then we can just say self.text component dot draw, or just :draw instead. And this will draw the text component for us because it already has its own draw function. Cool. Now that's the basics for the button. We'll be getting back to this a little bit later in the tutorial. I just want to get the button on the screen right now. Next we can go and we can create a new file in the states folder called menu.lua because it's a new state we have. And then you can require love, so local love is equal to require love local button, and it should be with capital B, is equal to require components.button. And then we can say function menu takes in nothing yet, and then we can just return a table, and we can return menu, and this will return a menu for us. Now we can just take in the game and we'll get to Y, and then the player and we'll also get to Y. Next we want to draw the buttons, and the buttons are pretty big, so local, and let's just draw one for now. Buttons is equal to, and then here we say a new button. The function we have, we can just say nil for now because there's no function. Then the text color, which can be nil, and then nil again for the button color. The width can be love.graphics.getWidth divided by 3, and we'll give it a nice rather smallish width. And then the height can just be 50. The text can say new game. It can be aligned in center. I need to make that lowercase c. The text size can be H3 or the font size. The button X position can be love.graphics.getWidth divided by 3, and it will kind of make it a little bit in the center. And then love.graphics.getHeight, and this is for the Y position, and this can be times 0.25, and it will kind of make it go a quarter way down. Okay, so these are our buttons we have. We'll add more a little bit later. So here we can just say draw as a function is equal to function taken self for, and then underscore button in buttons. So for every button we want to draw it, and so we just call button : draw. Cool. We have just created our menu. We'll get back to this a little bit later. We can go all the way up to load. And now we don't want this start new game anymore, because we don't want to start a new game as soon as we start or as soon as we boot it up. We want to go to the menu first. So we say menu is equal to menu game player. So just pass in these two into the menu. So the menu has to be below the player and the game. Now here in the love.mouse pressed, we can just add a global scope variable. We can go here, else, and just say clicked mouse is equal to true. So if the mouse has been clicked, we'll use this later, but we don't have to worry about it now. It's just so it exists. Then we can go down here, and where it says if game state is running, we can go all the way to the bottom, and we can go else if game.state.menu. So if it's a menu state, and we can say clicked mouse is equal to false by default. And we'll get back to this a little bit later as well. And then finally, here in draw, else if game.state.menu, and we can say menu : draw. Now when we run the game, we should be able to see a button on the screen. Okay, so it was the first attempt, so Oh, okay, we haven't imported menu yet. That makes sense. So we can just go here, say local menu is equal to require states.menu. There we go. There we go. So we have our first button. It just looks like text because the button color itself isn't a different color. We could, if we wanted to, change the button color to be something different. So here is our menu, where we set the button color, which would be this one. We can go R is equal to G is equal to 1, and in blue is equal to 0. Now this should give us a yellow button. So there's the button. I just made it the same color as the background to kind of make it more mystic, so it kind of looks like there is no button, but there is actually a button. We can just say nil back here again. And we have just created our first button. Now let's draw our cursor or mouse. Because if we go here, we can't really see our mouse. So we can just go if not, and then game.state.running. And we're not putting this inside of this menu checked state here. We're putting it inside of a not game state running. The reason for it is because sometimes we want to see the cursor even if the game state isn't necessarily running. For example, on the game over screen, we might want to see the cursor. In the settings screen, that's maybe another state, depending on how you code the game. You want to still see the cursor. In the paused state, you still want to see the cursor. So it depends on what you want to do here. Here we're just saying if it's a running state, remove the cursor because we already have the player on the screen. We don't want the cursor as an extra annoyance. And we can just say love.graphics.circle. And we can specify fill mouse X, mouse Y, and then 10. If you want an extra nice kind of challenge, you can draw the player cursor the same way you draw an asteroid. So then the player cursor is an asteroid. That can be pretty cool. Or you can make the player cursor like the spaceship as well. But then you move it with your mouse. It depends on what you want. Personally, for me, this little circle here, that's all I need, as you can see here. So it's a nice little circle that just shows my cursor. Now let's finish implementing the button, because it's a pretty big thing we got to implement, but we did the biggest part, so it's not that big of a deal now. So first, I would like to add a function to make it easier to change the button color. Now I want a way to make the button color not only settable outside of setting the button color on create, but to also make it easily settable anywhere in the game. So we can say set button color is equal to function. We take it self, red, green, blue. Then here we say self dot button color. And I'm just going to copy this because this is quite a thing to type out. We can go here, say that is equal to, and we just say red, green, and blue respectively. There we go. Now it's very easy to set the color. We just say set button color and we specify the number. We don't necessarily need to specify the RGB anymore. Next, we want to do the same but for the text color. So I'm going to copy this, paste it, and instead of saying button color, we can say text color. Red, green, blue, but instead of button color, we can say text color. Easy. Now, below the draw, we can also get or set a few methods here to get the position of the button and the position of the text. So get pause. You could also make this get button pause. It depends on what you want to do. But saying get button pause will kind of work with all of these, like set button color, set text color. So saying get button position would be smart. Pass in self, and we can just return self.button X and self.button Y. We just separate them by a comma, so we're getting two values from this function. 2 of them, not just one, so take note of that. We can then go get text pos, and we can actually just copy and paste this, to be honest. So get text pos, and instead of button X and button Y, we say text X and text Y. Cool. We have just implemented a ton of functions that could be useful in the future. Only 2 more to go. I also want a function that once we click the mouse, like once we click, it should basically execute the function we have passed in here. So down here, you can just say click is equal to function, takes itself, and we can just say func. So it will just execute the function we have. Doesn't do anything special, that's all it does, it just executes that function. Cool. And then the last one is just check hover. So we want to check if we're hovering over the button. So if the cursor is currently hovering over the button. That is equal to a function that takes itself, the mouse X position, the mouse Y position, and then the cursor radius. Then we can just do this. I just pasted it in, but I'll explain it. So you first get the mouse X and then plus the cursor radius. And I have explained this quite a few times, especially in the first tutorial where we did the balls. Basically, if a circle, or we have a circle, but we want to add the radius to that circle. In this scenario, since the button X is here, we want to add a radius to it both ways. That is why the button X here has the plus radius and then the button X here has the minus radius. If you haven't seen the previous tutorial where we did build a game where we like play around with balls, then I do recommend you go watch that tutorial, because it is quite a good intro to this tutorial as well. So I don't have to re-explain this right here, because that just does everything the same as what we did with for a player back then. So we just check if the mouse X and Y is above a button X or and Y. If it is, we return true. So here's the X and then here's the Y checking. If it is, we return true. Otherwise, we just return false. Cool, and that is all there is for the button. Next is the menu. Let's finish up here. So let's go here and create a bunch of functions we might want to do. So local funcs is equal to a table. First, we have our new game. So this is when they click the new game button. That is equal to a function. And this function just goes game, colon, start new game. And we pass in the player. And that is why we needed the player and the game passed in. We also want a quit game function. So if they click the quit button, which we'll put in a second. So quit game is equal to another function. And then love.graphics. Not graphics, that should be event. My bad. .quit. And this will quit the game for us once we click the button. Cool. Now we have our 2 functions we want to use. This button here, I'm going to copy and paste it 3 times. First here with this nil, I'm going to pass in funcs.newGame. Take note, however, I'm not passing in brackets. I'm not doing that. I'm just passing in the name. No brackets. Take note of that. And here at the bottom one, you can just say funcs dot, and then quit game. Yet again, no brackets. Okay, then with this button here, we can change the text here to settings for the settings button. And since all of the buttons will be positioned below each other, the x-axis, so this get width part right here, can stay the same. But since they're pushed below each other, we can change this right here to 0.4, and that will make this button here a tiny bit more below this button right here, which is the new game button. And in here, of course, we can say instead of new game, we can just say quit. And instead of 0.25, we can say 55. Nice. So we have just created our buttons and the functions that go with them. Now let's see if they get drawn. And there we go. New game, settings, quit. Now we need to do a few checks. So once we hover over a button, we want it to change color to red. And if we click a button, we want to execute a specific function. So let's go down here, and first we can say focused. That will be in empty string. And then we can create a function called run. And this function just takes itself, and if we have clicked, we can then get the local position of the mouse, so mouse X, and mouse Y, which is equal to love.mouse.getPosition, as we return both the X and Y position. And then we can go for name and button in buttons, so the buttons we have here. We can check if button and then check hover, which we have just implemented. We can pass in the mouse X and then the mouse Y. If you wanted to, you could have just made this mouse X Y already implemented inside of the check hover, but here I just pass it in because why not? And we can pass in 10, and this will be the cursor radius we have. I recommend you make this a variable instead, that's maybe global or passed in or something like that, because if you ever want to change the radius of the cursor, then you have to come back here and change it as well. So I recommend you make it like a variable and maybe pass it in here or something like that. Anyhow, so if the cursor is hovering above the button, we can just say if clicked, and we get clicked passed in here, then button colon click. So we want to execute the button function we have. And it's itself.focused, and this is basically if the button was not clicked in a sense, but it's not inside of an else, is equal to name, or we make it equal to name, and I go button and then set text color to 0.8, 0.8, 0.2, and this should also be 0.2. As we'll give it a nice reddish color when we hover over it. Else, we want to say button set text color 111. Currently this focused, we are not using it. We'll use it a little bit later, but it is there for once we want to use it. Cool. The menu has now been coded, but we are never executing this run yet, so we need to go and execute this run. Now it is pretty simple. We can just go here to main.lua. Here we say mouse clicked is false. We can just say menu colon run and then mouse clicked, or clicked mouse. There we go. And just like that, we have implemented the menu. That was like the last line of code. However, if we hover over it, we were not getting anything yet, so something might still be wrong. However, the buttons work. So if you go here, click quit, it works. If you go here, you say new game, it starts a new game. So the buttons work. However, the color is not changing yet. And right here, where we have this love graphics set color, this should actually be self.text component colon set color. Which if we were to go to the text component here, it has a function called set color, where it sets the color for us as well. So it has its own color function. We can then take this, what we have here, and we can paste it in here. That is why it didn't go the color we wanted it to go to. And now we have our button colors as well. If we click on settings, that will do nothing but just print out some text. If we click quit, that will quit the game. And then finally, if we say new game, it will start a new game where we can crash and we can shoot and whatnot. Alright, that was a pretty big tutorial. Well done if you sat through the whole thing. So in this tutorial, I'll be telling you all how to install LuaRocks on Windows. Now, as far as I know, there are 3 ways you can install LuaRocks on Windows. The first way you can do it is by getting the executable, the .exe file, downloading it, and then just using that. However, it doesn't work for me, so I'm assuming it also doesn't work for a lot of you. Another option is to compile it from a source, meaning you have to take the source code for LuaRocks and you have to compile it yourself, which I don't want to do, and I doubt that anyone else would want to do. Now the third option is to use Windows Subsystem for Linux. So this is basically where you have a type of Linux on your computer. And I'll be showing you how to not only install or set up Windows Subsystem for Linux, I'll show you how to work with everything you need to do in order to install everything you need to use for LuaRocks. Now to make sure we know how it works, I created an example which we can use if I will full screen this. So here we have a main.lua and this file sits here. Right here, so there's main.lua and there's text JSON, which is inside of my documents. Now here, we just read a file. As you can see here, just ignore this part. We read a file, and then we take that file, which has JSON inside of it. You don't need to know what JSON is. You can just copy and paste this into your own text.json file. Anyhow, then we decode it into a Lua table. So we take the JSON and we convert it into a Lua table. And then we access the content inside of it. And we're doing all of this using the Luna.json module, which we installed through LuaRocks. So let me give you a walkthrough on how to set everything up. First, you need to enable Windows Subsystem for Linux, or WSL. You can just say, turn Windows features on or off. If you click on that, you should be prompted with something such as this. Just scroll all the way down until you see this Windows Subsystem for Linux. If it is not checked, then check it. So mine is currently checked because it is already turned on. So you need to check yours if it's not already turned on. Then you can say OK, and it will install it for you. This will take a few minutes, so just give it some time. After it has installed it, you want to reboot your system so it can complete the installation. So you want to go power and then restart. It's going to say it's updating, but all it's actually doing is installing Windows Subsystem for Linux. Now, once your system has rebooted, you need to install Ubuntu. Luckily, you can just go to the Microsoft Store, so Microsoft Store, right here, Microsoft Store. And in here, you can just search for Ubuntu. I've already searched for it. There it's gone. Ubuntu, like that. And then you can just scroll down until you see Ubuntu 18.04 LTS. You can click on that. And here it will say Get. You just click on Get and it will download and install Ubuntu for you. Once this has been completed, you can just scroll down here and you'll notice this right here. So this is the command you use to start this Ubuntu system. Now I'm going to copy that, so Control C. And then we want to open up either the PowerShell or command prompt. So either command prompt or PowerShell. I'm going to use command prompt so I can look cool. Open that up. Now, to make sure you look like a real hacker, you have to say color O2. There we go. Now what you can do is you can start up your Windows Subsystem for Linux by right-clicking. Right-clicking will paste whatever you have inside of your clipboard. In this case, I copied this, so it pasted this. And this will start up Ubuntu for me. Now, if it's your first time starting up Ubuntu with the Windows Subsystem for Linux, then you'll have to enter a username and password. This can be anything you want, just keep it simple so you never forget it. Then once you're here, it's pretty simple. First, you want to sudo apt update, like that. Press enter. It will ask you for a password. You say You put in your password, and it will commence to get all of the latest packages it has. Then you want to say sudo apt update, and this will update your Linux system you have. Now I just did an update, so I don't have anything to update, but it will prompt you yes or no to update all of your packages. Just say yes. Once you've said yes, it will update your Linux system to its latest version. Now that you have this, you want to install Lua and LuaRocks. So you can just say sudo apt, and just for in case you don't know, you can also say apt cache search, and this will search the repositories for what you need. In this case, if I say Lua 5, then here it throws out everything I can download. Now you can choose between Lua 5.1, 5.2, 5.3, and basically 5.0. I want to get Lua 5.3. So I'm going to say sudo apt install Lua 5.3. And I also want to install LuaRocks. I can just say LuaRocks. Once you do this, it will ask you to install it. You just say yes, I already have it installed, so it's not going to do anything. Now, once you have this installed, you can start executing your code. So make sure that right here, you have this code and this JSON file. Make sure you have these, because this is the example we're going to use. Now currently, I am not inside of my Windows machine, I'm inside of Linux. So to get into my Windows machine, I can go cd and then a /, not a /, but a /. This will take me to my root directory. If I say ls, it will show me all of the folders I have inside of this folder. You can just go into cd mnt for mount, and in here you'll see all your drives you have. So I have the C drive and the D drive. To show you an example of this, if I open up my file manager, go to this PC, then this is my C drive. As you can see, there's C, and here's the D drive. Now the C drive, we can go here, and as you see, there's the C drive. To go into that C drive, we can say cd C, and then a /. Now we want to go into users, and then here we can just say cd users. And take note, I'm using a capital case U here because this users also has a capital case U. Then here is Charisse the Brain. You can go into that. That is my current user, who I am. Then here we can also go Charisse the Brain. Then here, to find where my things are, yours might be inside of documents, inside of desktop, inside of downloads, inside of music. Wherever you put your files, you have to go. Mine is inside of OneDrive. So here I also have to go into OneDrive, and you can press tab to let it autocomplete for you. And in here, you'll notice we have a documents folder. If I go into documents, then you'll see I have a Lua folder, and this is where my Lua stuff are. Now I can just go here and say cd documents and then Lua and press enter. Now if I say ls, I should see a main.lua and a text.json. So right here, main.lua and text.json. Now once you are inside of here, you'll see these two here. To run this Lua code, you can just say Lua 5.3 and then main.lua. If I run this, I get Jack, and that means I executed the code inside of this main.lua. To see what's inside the file, I can say cat, which means read, and in main.lua, and you'll notice it's everything I just had inside of VS Code. Luna.json requires Luna.json, and in all of this. Now, one thing I did forget to tell you is how to install Luna.json, because I've showed you how to install LuaRocks. To install Luna.json, you can just say sudo LuaRocks install luna.json. And let me just resize it a bit so everything's on screen. Oh, so here we go, sudo LuaRocks install luna.json. And this is how you install any package in LuaRocks. You just say sudo LuaRocks install luna.json. We press enter, and there we go. So now it should be installed. And now, of course, if you try and run it, it will run your things. To uninstall a package from LuaRocks, you can say sudo LuaRocks. It should be remove luna.json, and this will uninstall a package. Now, if I were to try and run this code, it will tell me it doesn't know what luna.json is because I have uninstalled it. And then yet again, to install it again, I can just say sudo LuaRocks install luna.json. And just like that, you can use LuaRocks. Now take note, whenever you want to run something, you now have to run it inside of your Windows subsystem for Linux, meaning this right here. You cannot run it from Windows, not as far as I know at least, because luna.json and LuaRocks are both installed on Linux now and not on Windows. This is, to me, is the easiest method around this LuaRocks installation issue we're having. Today we will be implementing the user score system. Then, say start new game, you'll see we have now two score systems there at the top. Once we blow up an asteroid, the score increases. Go here, we blow up the asteroid, it increases, and in here we no longer exist. So you just boom, and let me just boom. Cool. Now when we go back in, I think the score is no longer there. We'll implement that later. But the idea is, once we have the score implemented, the score should stay as it is, and then we will have a high score and a current score. The high score will be implemented in a different video. It's not that complex, so we'll probably do it near the end. Cool. And just as a comparison, this is what we currently have. Move this up here. We say new game. As you can see, we don't currently have any score to speak of, which is unfortunate. So that's why we'll be implementing it right now, because that's one of the things that really makes a player more happy to see, is if they play a game like this and they have a score, and they try and beat their score every time they play the game. Now, let's go to our globals.lua. Now, I'm going to assume you have LuaRocks installed. If you do not have LuaRocks installed, I believe you can just Google LuaRocks. Yeah, there we go. And then you can install LuaRocks. LuaRocks allows you to basically just install extra packages or extra files for you to use in your programs. So let's say you want to work with MySQL, which is something you use to work with databases. Then you can go to LuaRocks and you can download this MySQL package, and now you can work with MySQL in Lua. Or if you want to make a chat app, then you can get this Lua sockets, which allows you to basically chat or create a chat app. Now I'm going to assume you have this already installed. And if you don't, you can just quickly go ahead and install it. Just pause the video, go and install it. It would be probably as simple as it was to install Lua, if not easier. Now, if you have it installed, make sure that you have the following in your path. You need to have LuaRocks in your path. So this should also be in the installation. If it isn't, you just have to implement or add it. You say $, and in brackets, LuaRocks path -- bin. And this will allow LuaRocks to work. And you have to add eval here at the front before this. So if we just copy this, then you have to go eval. And every time you want to use LuaRocks, you have to do this. What you can do is you can say, you can go into your bash RC, and this runs every time you start up your terminal. And let me just run that again. Now if we go down here, And actually it's at the way bottom, so let me just full screen that. So here we go there. So this is inside of my bash RC file, which runs every time my terminal starts up. So every time a terminal starts up, we make sure I can use LuaRocks. So I recommend you do the same if you're on Linux. Now once you've done that, LuaRocks should work. Now to install what we want to install, we need to type LuaRocks install and then Luna JSON. This package will allow us to work with JSON because I want us to save our file in JSON format, and you don't need to know JSON. I'll explain it along the way. A lot of people would actually prefer if you were to encrypt this save file, but I'm not going to go through all of that effort. It's such a basic game. That could be something you do on your own. But you might want to encrypt the save file so a player can't spoof how much they really got. For example, let's say they really only got 5,000 points in the game. Then you might want to encrypt the file so they can't just go into the JSON file and change that 5,000 to 50,000. But that's out of the scope for this tutorial. So we can just say install. And let's see here. And I do not have write permissions. I'm just going to go sudo and then try it again. You might want to use -- local if you have the same problem. I'm just going to go sudo just to keep things simple. Now once you have this installed, you should be good to go. Now let's go up here and we say local Luna JSON is equal to require Luna JSON. And we can use it just like with Love because we've installed it. So now we have this option here to use. Now we can create a function, and this function will be called read JSON, and it will read a JSON file for us. And in here we can just pass in the file name because we might have multiple JSON files we want to read. So this is just for future proofing. You don't have to necessarily add a file name here, but just in case you add another file that you wanted to read, then it easily reads that file for you. Now I recommend having all our files inside of a specific folder. So right here we can create a new folder and we can call it SRC for source content. This can be like your audio and your files and your images and whatnot. In this case, we can just say data, and that should be a folder, data folder inside of the source folder because this is where all our data files would go. Preferably encrypt your data files because this is usually things users should not be tweaking. And in here we can just say save.json because this will keep the save file or the save data. And then all we have to do is we have to use these curly brackets. And then we just have to say high score like that, or if you want you can also use an underscore like that, but preferably don't use a space. That's not very good. So use an underscore or a capital case, but not a space. And you can just say 0, and this will be the score the user has. Save that, and you don't have to open this file for a long time. Cool. Now that we have that file, we can specify the file we want to read, so the file we need to open. So local file is equal to IO for input output dot open, and we pass in the file path. So you can say src, so that would be this src file or folder. Then you want to go into the data folder, so /data, and then / because we want to access this save.json. We can then just go .. file name, and then .. because you might not want all of your files to be in .json format. You might have multiple formats. .json. Now this is just how I did it in the script, but because this is saying read JSON, you can just as well not have this here and just let them enter JSON. But because I just want to enter the file name, for example save, I just say that, then it will automatically add this .json for me, as you can see here. The end result will then look something like this. And all I had to do was enter save here, and it will produce this. And then of course here we just have to specify we want to open it up in read mode. Below that we can say local data is then equal to file colon read, and we can just say we want to read everything. So star and then all. This will read everything inside of this file. And we can say file colon close because we don't want the file to stay open. And then return luna.json dot decode, and we can just say data. Now once you have done this, everything should be still working fine. If you want to test it, you can still run your code of love dot and make sure everything starts up, which it should. Cool. Now next up we can go to this game.lua file, because we now want to add the high score to the game, because we can now read this JSON file we have, but we want to have it display the score here. Now this JSON.decode here, before I forget, basically just converts JSON, so this right here, to a Lua object, so Lua table. Now down here we can say score by default is 0. So by default, when you start the game, you get 0 as the score. This is the initial score for the game. And now here at the top, we also want to import save data, because now we want to read this file, this JSON file. Then we want to pass in the save data into this game here. If you want to, you could load the high score and all of the save stuff inside of this game here. But for me, it's better to rather do it outside of the game, just to keep things simple. So if you might have different functions you want to pass the same data in, then you don't have to make multiple functions in each one of those. You can just pass it in here. But we'll get to that a little bit later. Then you can say high score is then equal to save data dot high score. And this here is just a table. It's just going to contain high score for the moment. If there's nothing there, we want to say or 0. So it will default to 0. Next, we want to go a bit down here to where it says draw, because we want to update the draw. We can go up here and say local opacity is equal to 1. Then if faded, then here we just want to set the opacity to 0.5. And now I can just work off of the opacity. So we don't need this if statement here anymore. We can then just unindent this. Actually, this can still be inside of faded. Why not? Because this should only be displayed if we're currently faded. Because only if we're faded, we're being paused. That's the only time currently the game is ever being faded out. So this can still stay in an if statement, now that I think about it. And because this should be above everything else, it should be at the bottom of this draw. If it's at the top, everything else is going to be above it. So it should be at the bottom. We can then go text to create new text we want to display. And you can just say colon draw. Then this text we want to say score. And this will be the default score the players see like when they start up a new game. Colon space and then add the self.score. Then we can position it -20, 10, and I don't think that's positioning. I can't actually remember what is everything inside of this text here. What are we doing? Okay, so first, oh yeah, so that is positioning for X and the Y position. Cool, okay. Then the font size, that will be an H4. We can say false and false, and the false and false is just for this fade in and fade out because we don't want it to fade in or out. Then we want to wrap width, the line, and the opacity. So the wrap width will be the width of the window. So love.graphics.get width. And then we can say right and then faded and opacity or 0.6. Now this is a little bit weird, but basically if it's faded, then show the opacity we have. Otherwise, just default to 0.6. And I believe you can actually go here into the Lua virtual environment and just test it out. So let's say we have X, which is equal to true. And we have 1, which is equal to, let's say 0.5. And then 2, which doesn't exist. So you can just say 2 is equal to 0. Now, if x and 2 or 1. We get 0.5 because 2 does not exist. But if we were to say 2 is equal to 1, then we get 1. So if x is true, which in this case if faded is true, and this right here has a value inside of it, then display this one here, so opacity. Otherwise, if this has no value inside of it, and this is false, then display this. So that's for that. Now we can copy this, and we can do the same for high score. So here we say high score. And now here, instead of dot score, we can say dot high underscore score. We can then make this 0. Yet again, 10, because it's going to be the same height. We can make it h5, because this shouldn't be the main attraction. The main attraction should be your score, so it's going to be a little bit smaller. Before we go, that right should be a center. And we can also change that 0.6 to 0.5. Cool, and that should draw it. So let's just save, and then let's run it and see if it works. Because that should theoretically draw it. Ah, here we go. Attempt to index local save underscore data, nil value. You know why it's giving us that? It's giving us that because inside of the main.lua, if we go up here, we are not passing a value in here. So we don't have a high score. I'm just going to say 0 for now. And let's run it and see what we get. Ah, we still get a value, or still a problem. And my bad, this should be a table. High score. There we go. And that should be an equal symbol. There we go. Now it should finally work. New game. Now we have a high score, which is a little bit faded out because remember, the main attraction is actually the player and the asteroids. And then the score is also a little bit faded, but it's bigger because you might want to see your score more than what you see your high score. Alright. Now, one thing before we continue, this right here, quite unnecessary because all we need to do is we just need to get the data from globals. And we are already requiring globals. So all we need to do is, let's say, it can be maybe like the second thing it does. Local save underscore data is equal to, and we can just say read JSON and then save because we want to read this file. And you can just take this save data and pass it in here. Or if you really want to save space, you can just do, whoops, my bad. You can just do that. But I like doing this just to make it more readable. Now let's make sure that works because that should read the file for us, and then once it has read the file we should see that value. So let's go up here and just run it. Okay, high score is 0. Let's keep a look out for that. If we change the high score to 900, what do we get? Do we get the same output or did it change? Because it should be changing. New game, and there we go. Now we get 900. So we have successfully created a save file and read from that save file. Then last but definitely not least, we now have to modify the asteroids a little bit. Because when you blow up an asteroid, your score should increase. So let's go right here and we can say if self.radius is more or equal to asteroid size, then so the radius is more or equal to the basic asteroid size. Of course that's a little bit big, so we want to go divided by 2 because asteroid size is from left to right whilst radius is halfway. Then game.score is then equal to itself, so game.score plus 20, and the game now has a score on it. If we go here, you can see there's the score plus 20. We can then go else if, and we can go self.radius is less or equal to the min asteroid size, then we can do the same thing as this. But because this asteroid will theoretically be the smallest asteroid you can get, we want to make them get a lot of points for destroying the small asteroids, because they can be difficult to shoot and they multiply, so they can also be very difficult to dodge at the same time. And then finally, for the medium-sized asteroids we can just say else, copy this, and instead of 100, we can say 50. And then this isn't something that's going to really affect us too much now, but we can also go if game.score is more than game.highscore. Then we want to say game.highscore is equal to game.score. Now this right here is basically whenever the player plays and their score is higher than the high score they have, then the high score will also increase along with their normal score. Kind of to tell them, hey, you are getting a new high score. Good job. And this here will of course just add a score. And we're already drawing the score to the screen, so we don't have to worry too much about that. We're going to just say Love2D to run it. Move it so everyone can see. Start new game. Shoot. You'll notice both of these, the high score and the score, increases because the score is higher than the high score. And of course, the more we destroy, the more we gain. Now, take note of this last part we added here. If we make the high score, let's say 100, then if we go back here, we say start new game, and we shoot an asteroid. My aim. As you can see, the high score didn't change, but the score did. And the high score won't change until our score is higher than the high score. Then you can see the high score is starting to change. Cool. And that is implementing a basic save or score system for our game. So to give you an idea of what we'll be doing, here we go. We say start new game. Just wait for that asteroid to come back. And then one last time for our last health right here at the top, our last life. We crash. Oh gosh, missed it completely. And then we get a nice fading game over screen. And it fades out. And after it fades out, we get new game. So first of all, I would like us to go to this menu file right here. Or not menu, I meant to say main. And here at the bottom, where we say game.state.menu and game.state.running and paused, whatnot, we want to add one more else if. We want to go else if game.state.ended. So if the game state has ended, then we can just say game:draw, because it has to now draw the game ended state, but the game will already know what state it is. Cool. Now currently, this won't really do much. If we were to run the game we currently have, and we were to test it out. Here we go. Oh gosh, missed it. This one has a bad collision. Then as you can see, we just get a dark screen. We don't really go anywhere, nothing's happening, because the game over state doesn't really have anything to draw yet. So let's actually add that. We can open up our game state, and we can start here at the top. Underneath high score, we can add screen text. And a screen text is just a table that will display the text on the screen once we go to game ended state. This will remove it and add it and whatnot. Then we need to add another variable here saying game over showing. And this is for the animation, so we know when the game over is showing and when it is not showing. So we know when to switch from showing the game over state screen to showing the menu state screen. So that can be false by default. Next here in change game state, we can go if self.state.ended. So if the state has ended, then we can call the self game over function. Now this game over function is what we're going to create now. Basically, it's going to do all of the game over stuff for us. So let's go here and say game over. That's a function which takes in self. And first we can set up the screen text, so the text that should be on the screen. So self.screenText is equal to a text component which contains the game over text, which will fade in and out. You could also maybe do the same and then also display the high score and the player score, also fading in and fading out or whatnot, something along those lines. That could also be a very smart idea. However, we're going to keep it simple and just do the game over screen. Just game over and then poof, done. We can say 0 love.graphics.getHeight times it by 0.4 to kind of get it in the middle, in the center, because you should remember how fonts are used. It's not necessarily starting in the middle of the font as well. It starts here at the top. So every letter has a top point and it starts there instead of in the middle. So you should just take note of that. It can be size of h1 because it should basically take all of the attention. It's the most important. And say true love.graphics and then get width and then center. Now if you're wondering what any of this means, you can always just go back to this text file right here and just look at what all of these mean. You'll notice our fade in and fade out right here is now set to true. Nothing else is basically set like this. So this is the first time we'll be really using this fade in and out functionality. Then after we have done that, we can just say self.gameOverShowing, and we can make it equal to true because it's currently showing the game over. If it's not showing the game over and the game state is ended, then we should know that we want to switch from game state ended to game state menu, because it's not showing game over screen and the state has ended, so there's no point in showing it anymore. Now currently this won't do too much. Then right here inside of the main.lua, we can just reduce the amount of lives the player currently has. So player, and it takes the lives, so num lives, and we just make that 1. Now if we run it, we should be able to see our output. Now it should work. We say start new game. We uninstall live.exe. And boom, that is all we get. So not really anything just yet. So let's go down here. Because currently I didn't really think about it, but this doesn't really draw to the screen. So we put the text there, but we never actually drew the text. So let's go do that inside of this draw function. And let's go right underneath faded. We can then say for index text in pairs self.screenText. And we can say if self.gameOverShowing, then, and now here we want to draw all of the things while the game over is showing. So self.gameOverShowing is then equal to text draw self.screenText. So it's going to draw the text that should be on the screen. And then we can just say index. If we're wondering what's going on here, we can go here to text. If we go to draw, we take in the table text and then its current index. You'll notice return true or false. That's how we know if we're supposed to show it or not. If it returns false, it's not currently drawing anything to the screen. If it returns true, it is drawing something to the screen. And if you plan on adding more things here, you should just modify this a teeny bit so it can be able to do this more dynamically, because currently it's good for one thing, but if you have 2 or 3 things, it's not going to be that great. Anyhow, then you can say if not self.gameOverShowing, then, so if the game over is not showing, then self colon change game state, and we're going to change it back to the menu state. And then otherwise, if the game over state isn't showing, then we can just say else text draw self.screenText and an index. So this will basically start it off. It will start the draw. So yeah, that is about that which we'll need. I don't think we'll need any more. So let's try and run this and see what we get. If we just drag this here so everyone can see, start new game and end, then we start getting a fading out game over screen. Thanks to everything we have already implemented and why I did so much work at the start of the game, we don't have to do a lot now because we've already implemented fading in and fading out. And that is for the game over screen in Love2D. So in this tutorial we'll be implementing new levels as well as making the player invincible. Now after this tutorial the game is going to be a little bit broken, but we will be fixing that in upcoming tutorials, so don't worry too much about that. Now to give an example of what we'll be working with, what we'll have by the end of the day, I just move this here. Now when we start a new game, you'll notice the player blinks, and if I try and go into this asteroid here, nothing happens. That is because of our new invincibility we added. So when we start a new game or when the player dies, then they finally become invincible and they cannot be hurt for another while. And this is very useful because let's say you have 20 asteroids on the screen. It can be very difficult to avoid them immediately once you respawn. So if you're invincible for a few seconds, not only does that give you some time to clean up the screen, it also makes sure that you just don't immediately die once you respawn. Now to make sure that this works, if we crash in here, we'll actually explode. Then now we can try and crash into things again, and we won't. As for new levels, we can just shoot these asteroids, and I'll show you all the new levels. And one more here, right here. There we go. So now we have level 2, and there are now 2 asteroids. On level 3, there will be 3 asteroids, level 4, 4 asteroids, and so on. But it becomes more challenging because each asteroid explodes into multiple more asteroids. So it will become more challenging depending on how everything goes. Now a bug you might encounter here is, let's say you die at level 2 here. So just give me a second. There we go. If I crash against something, it tells me it's game over. But once this game over screen leaves and we want to start a new game, then you'll notice we're kind of still in the middle of a game, but not the same game. It's kind of weird. Now this is normal. We are going to fix this. In fact, if you want to, you can try and fix this yourself before the next tutorial. But it's just normal because we're going to play around with some of the code and it's going to cause this to happen. Okay, so let's try and implement that. Let's go to our state and open up our game state. And let's see here. Where are we now? We are now at draw. Okay. Then here in start new game, we're going to add a few new things. So at the top, we want to go if player.lives. So the player lives is less or equal to 0. Then you want to change the game state to ended. So this will kind of fix a few bugs, but it will also make sure we don't just start a new game, because every time we level up, we basically start a new game. So if their lives is 0 or less, that means the game has been or should be ended. So let's go here and we say self colon and then change game state to ended. Else, if that's not the case, if they still have lives left, then their game state should be set to running. This means it won't be going to the menu state, for example, or to the paused state. It will go right to the running state. And now we can remove this one right here because we don't need that anymore. Then we want to say how many asteroids we want to spawn. So we can say local num asteroids, and that can be equal to 0. And here we have our asteroids. And now let's say they do level up. We want to display the level on the screen, even if it's level 1. If we run this, new game, it says level 1. So even if it's level 1, we want to display this on the screen. So we can then say self.screenText is equal to text. And in here, we can just pass in all our required parameters. So first the level we are in, level, that should be level, with a space, and then concatenate that by adding these 2 dots and saying self.level. So getting the current level. We'll say 0 love.graphics.getHeight, and we just times that by 0.25. So it won't be quite in the center of the screen, it will be a little bit above the center of the screen. And we can just add a comma there. We can then say h1 for the text size, true, true, love.graphics.getWidth, and then finally we want to position it into the center of the window. Okay, so currently we also have another problem we have to look out for. Every time we start a new level, there's a small possibility that once we start the level, the asteroid might appear on the player. So we don't want the asteroids to spawn on top of the player. We want the asteroids to spawn anywhere around the player. So to get this, we want to create an infinite loop. And this infinite loop will basically determine when and where everything should be spawned. So let's go create a for loop first. And you can say for I becomes 1. And until I is num asteroids, so the number of asteroids, plus self.level. Then we want to go local, and in the asteroid X, so these we have here, and we want to say local ASY for asteroid Y. I do believe since we're not really putting anything next to them, we could possibly just go like this, and this should be fine. But just for convenience sake, I'm going to do this. And then at the end of this for loop, we want to insert into the table, just like we usually do. However, this time we won't need to specify a specific size. We can specify the asteroid size, because then we have our specific asteroid size we want to spawn. We can then remove this, and in between this local and this table insert, we want to create an infinite loop that will reposition the X and the Y until it is no longer on the player. So we can say repeat until, and we want to repeat it until the calculate distance from player X and player Y, and we want to say the asteroid X and the asteroid Y, and if that is more than the asteroid size times 2 plus the player radius. So we're checking if the distance between the player and the asteroid is more than the asteroid size times 2 plus the player radius. So it means if the asteroid can currently damage the player was not invincible. Then we want to regenerate this ASX and ASY. So let's just put that here, and let's just put that in there as well. So it will run at least one time, and then it will try and figure out if it should run again. And it will continuously rerun this code until the asteroid is no longer on the player. So if the asteroid is no longer on top of the player. Now this isn't really required, but I do want to just go on top here and say require globals. because we are now using a function that's inside of globals, but it's not really required. Okay, cool. So it's not really a guarantee we're going to see this change, because we haven't really seen it in the past, so it's not really guaranteed we'll even see it now. But if we run our code, it should work and nothing should be broken. Let's go like this, say start new game. Okay, and as you can see, everything still seems to work. But now, the difference is the asteroid will always spawn a relatively far distance from the player, so that they have like a little circle they at least have to themselves. Okay, I also see here we only have 1 life left, but that was for development. We can remove that later, it's not really required now. Next up, we can open up the player so we can add the invincibility to the player. So we're going to know how long the player can actually be invincible depending on how many times it has blinked, and this will also indicate that the player is currently invincible. If I were to just show the example again, you'll notice the player blinks, and at least to me as a gamer it says, hey, this player is currently invincible, nothing can really touch it. And once the blinking stops, you're also no longer invincible. So here you can say how many times you want it to blink. So local usable blinks. And this will be the amount of blinks you wanted. In my case, I only wanted to blink 10 times. But then times 2. We're adding 2 to it because of how fast the blinking is compared to how long the player is going to be invincible. Okay, so let's go down a bit. Then let's go right above the lasers. And we can say invincible is equal to true. So this is if the player is currently invincible, if we cannot touch the player. Let's make that invincible, not invincible. And here we can say invincible seen, and then we can make that true as well. This is if the player is currently grayed out or not. So you'll notice we go from white to grayed out, from white to grayed out. This will say if the player is currently grayed out. And here we can say time blinked, and we can make that equal to the current usable blinks. So this is the amount of times the player can blink while immortal. Cool. Now let's actually implement the design for all of this. So let's go to draw flame first. And let's see here. Right above everything, we can create an if statement. And we can call it self.invincible scene. So if we currently are in the invincible scene state. Then we want to say table.insert into color 0.5. And that's being passed in right here, so the color. And we're just basically setting it to 0.5, which is half its opacity. We can close this function again, and we can go to draw. And this is where most of the things are going to happen. Let's go here into the else, or not the else, but the if statement here. And right underneath debugging, we can implement if the player is currently invincible, and what should happen. So if self.invincible scene, then you want to say love.graphics.setColor 111, and then faded and opacity, or 0.5. So this will basically give us our default faded / opacity we want, or it will just default to 0.5. Cool. And in here we can just say else, and we can copy this line, paste it here, and we can just move this line up. We don't need to copy or paste any lines. And then we'll have this instead. Next up, we can close this function and go down to maybe the move player right here. We then want to take in dt, and this is the time between the last frame and this frame. For anyone who may have forgotten, this will allow us to calculate when the player should blink. We can then say if self.invincible, then we create an end here, self.timeBlinked. Make that equal to self.timeBlinked plus, actually minus, dt times 2. So this will first take the dt, times it by 2, and then take what we have, our current time blinked, and subtract it from there. We can then go on every uneven blink and make the player fully visible. So on every uneven one, for 1, 3, 5, the player will be fully visible and not grayed out. To do that, we can say if math.seal, pass in self.timeBlinked, and then modulo it by 2. And this is an easy way to see if something is an even or odd value. So in this case, if something is an even value, it will be true here, because 2 modulo 2 is 0, 4 modulo 2 is 0, 3 modulo 2 would be 1, because there's 1 left. And then just say self.invisible scene, make that equal to false. Otherwise, we can say self.invisible scene and make that to true. Then we can set if the player is invincible and make it false if the time blinked has ended. So if self.timeBlinked is less or equal to 0, so if the time blinked has ended and there's no longer any reason to blink, then we can just say self.invincible and make that false. Otherwise, if the player currently isn't invincible, we can just set self.timeBlinked equal to usable blinks. So we're basically resetting it. And then self.invincible scene becomes false. That's about that for the player. And I don't believe it will be working just yet. So if we run it, the player will most likely not be blinking. Yes, because we even haven't passed in dt yet. Okay, to pass in dt, we can go to the main.lua file. And right here where it says move player, we just pass in dt, which is provided to us by Love2D. And then in here, where we say if not player.exploding, we also want to now go and not player.invincible. Because if the player is not invincible, we are allowed to calculate the distance and make sure that the player is or is not exploding. But if the player is invincible, we don't want to do that. Cool. And let's see here. Right before this else if, we can go if the number of asteroids is equal to 0. So if there are no more asteroids left, we can increase the game level. So game.level is game.level plus 1, so it's going to increase by 1. And in game, start new game. And we can pass in the player, and that will basically generate us not only a new player, but a new game for the new level. Great, now we save this file, and we run it. Say start new game. Now the player will blink if we try and hit something. We can go straight for it, and you'll see the level fade in and out. Now when we destroy this asteroid, it should increase the level because there will be no more asteroids left on the screen. Can go here and just... There we go. So now it's level 2, and the asteroids also spawned very far away from us. So there's no chance that once we go up a level, an asteroid will spawn directly onto us. Cool. Now let me just increase my life here so we can make sure if the player does end life, we can respawn without a problem. Let's go here, and wrong one. Start new game. Okay, we can go through this asteroid, we can shoot up this asteroid, and go to the next level. Let's try and go to level 3 just to make sure that all leveling systems work. Thanks to how we built the game, implementing levels is fairly simple. It's auto-generated, so come on, you can do it. Come on, there we go. Yeah, so now there's level 3. If I hit something, okay, then my hitboxes aren't the best. Okay, now we're invincible again, and we can fly right through stuff without getting destroyed. Until we are no longer invincible, where we'll explode if you try and touch something. Cool. And that's the gist of it. Now, one thing I did want to show you, but I kind of forgot in the previous tutorial, is kind of to show you an example of how we created the spawn before we get to the actual video, is if we were to go to the, I believe it would be anywhere like in a game or something, or just we just spawned the amount of asteroids. Yeah, so here is the num asteroids. Now when we play the game, if I go love dot and we start the game, new game, then as you can see the asteroid spawns far from us. But how do we know in the previous tutorial what we implemented really works, that the asteroid will never spawn on top of us? Well, when we go here and we change this to maybe 100 asteroids and we run it again, new game, as you can see we have like a little radius around us where it wouldn't touch us. Same with if we were to start a new level, it will spawn them all around us instead of at us. So if we make this 500 for example, and then we run it, then as you can see there's a little radius where they won't spawn on top of us. Also, I believe that level 500 is impossible. If someone plays this game and they get to level 500, then please show me how you defeat it, because that would be very interesting. Alright, so yeah, that is just what I wanted to show you, just to make sure you know that what we implemented actually works. So first off, one thing we have trouble with is if we actually start the game right now, and we just wait to immune ourselves. Oh wait, we can like start a new level and whatnot. Okay, now we explode. Okay, that's fine. Let's continue. Okay, now I explode again. Now we have 1 life left, and then I can show you what I mean. Alright, so now when I crash into this asteroid, which I just missed, and it says game over. Now when we start up a new game, you may have remembered this bug from a previous video. If we new game, then we kind of continue flying off where we left off. So we just continue. If I die here, then it's just going to spawn me back at this exact location in the next game. Therefore, we should create a reset game function. So let's go into main.lua. And right above the love.load, and this could also be in globals if you wanted to, or you can create a utils.lua file or whatnot. But here we can say function reset, and this will just reset everything for us. And then here we can just say end. So first we can read the save data, so local save data, that is equal to read JSON, and then we can just put in our save.json, or in this case just save, we don't need to specify JSON. Underneath that we can then create our player, and that will just spawn a new player or create a new player object with 3 lives. We can then go game and we can create a new game object, save data, we can just pass that in, and then create a new menu object, which is equal to menu, and you can just pass in the game and the player, and then destroy asteroid, we can make that equal to false. Now this destroy asteroid, you might have forgotten about it, but if we go to our globals.lua, and we can actually keep this here, then you'll notice here, destroy ast. Just so you know where we are coming from, and here we're just making it false again, in case you may have forgotten where this is. Then after that, you basically have created a reset function. So what we can do now is we can remove this as well as this right here, and we can just say reset. Because this player, game, and menu and destroy asteroid are all global because they don't have a local in front of them. So they can still be used once we use this reset. So now we're going to reset the game once we start it. And whenever we die, we want to reset the game again. To do that, we can go down to where update is. We can scroll all the way down till here where it says game.state.menu. Then we have our menu run click and then our mouse clicked, which is false. Then here we can check if not reset complete. And this is a global variable, but actually we want to make it local to this file but global in the file. So we can go up here and we can just say local reset complete, and we can make that equal to, and you might want to make this underscore complete or like this, depending on how you name it. When I scripted this video, it was probably like super late at night, and here I have like underscores and here I have camel case. You should just stay consistent, but I did this late at night, so I'm not consistent anymore. Anyhow, this will tell us when we want to reset the game once we're in the menu state. If it's true, we can just call reset, and then reset complete is true. Then here we can say else if game.state.ended. So if the game state is ended, we can say reset complete is equal to false. So if we do die, then the reset complete will become false. Then once we go into the menu state, it will reset the game for us. Alright, we can now just save and test this out. This should make sure that once we restart the game, we don't just continue. I'm going to just decrease the amount of lives I have because 3 is kind of unnecessary. So let's just make that 1 for now. But you could keep it 3. I just don't want to wait forever to be able to die. Alright, so let's see what happens. I crash. The game is over. Now what should happen is I should spawn in the middle of the screen again. So new game, middle of the screen, level 1, only 1 asteroid. So we have basically successfully reset the game. Cool. We can now just change the player lives back to 3. Save that. Next we can go to globals. Now here we want to write JSON. So we already have read JSON, but now we also want to write the JSON. So I'm going to copy that, paste it, change it from read to write. We can also get the file name, but then we also need to get the data we want to write. Now we are going to get a table and we want to convert that table into JSON so we can store it inside of our save.json, because this may look like a table, but this is actually JSON. Okay, so to make sure it works, we can also print it out to the screen if you want to, but we are anyways going to see how it looks once we put it inside of the save.json. So you could print it out to the screen, or you could just look how it looks in the save.json. Okay, so now we can have our local file, and we want to open it, and it's going to be the same file, but this time we want to open it in write mode instead of read mode. Then we want to go here and say file.file::write. And the only reason I'm getting this yellow lines is usually because you'd want to check if this file is nil or not first. If the file is nil, you don't usually want to try and write to it. So if you want to be safe, you can first check if file is equal to nil, then, and then you could just like return or something. Anything here would work. Or you could just do this if the file is not nil. So if it's not nil, then you want to do this. And as you can see now, the yellow lines are gone because we know file is not nil because we checked for it first. So yeah, that's just something you want to maybe take note of. I'm not going to do that right now, but you could. There's nothing wrong with it. It's actually better practice. I'm just not going to do that right now. We can then say Luna JSON dot encode. So first we used decode. Decode converts JSON into a Lua table, whilst encode converts a Lua table into JSON. Then here we can just pass in data, which we get here. They want to close the file, and then the function is done. We don't need to return anything. And this will write to our JSON. To make sure it works, we can actually just, that's already 0, so we don't have to change that. We can now go to game, because we want to save our high score. So once we boot into the game again, we have our high score there. So we can go to the top, and we can create a new function called save game, which is equal to a function that takes in self, and it just does write JSON, and then the file name, which would be save, and then the Lua table. In this case, we want to save the high score, and just self.highscore. And this should save the file for us if we get a new high score. Now, it won't just call itself. We need to still call this function. So here in game over, for right now, we can just say self : save game, and this will save the game for us. Let's try and run this and make sure we actually get that. So we can open this save.json so we can see what happens. We say new game, current high score is 0. But if I were to just go up here, you'll notice my high score also increases, but now we need to make sure it saves. So just give me a second and let's blow up. Now you get a game over. Our high score is 1110. Okay, we need to see and make sure that that high score is what we see. If I say quit, then as you can see, it updated our file. Now the high score is 110. Okay. Now I'm just going to decrease my HP by going here and just saying make it 1. Just so I don't constantly have to wait forever in order to finish the game. Now let's say we only get 1 score here. And as you can see, our high score is 110 now. And our score is 20. So our high score and our score are two different things at this moment. If we crash, we get our game over screen. And we go to our save.json. You'll notice our high score didn't change along with it. That is because our high score here never changed. So as long as this high score doesn't change, the high score we save will not change either. That is why we could just go here, and we didn't have to do any checks before, because we already do checks to make sure that this high score doesn't go over the normal score unless we get more. For example, if we go here, our high score is 1110. If we try and beat that high score, okay, so my high score increased as well as my score, as you can see, since my high score has been surpassed. So now both of them will be increasing, and once I explode, then the high score inside of save.json is also updated. So you'll notice that the high score only changes once the score is higher than the high score. And that is that for today's tutorial. This will be your final Love2D tutorial. However, to all of you who made it all the way here to the very last video, well done. You have all done such a great job getting here. And with one last step, you can finally continue on your road to being a game developer. Now before we continue, because I know a lot of you probably missed out a few pieces of code here, or might not know what to do after you finish this, you could skip this part if you want to, because it's not that important. But here we can just bring this over. So all of the code is on GitHub, and this link will be in the description. So if you miss anything, you can just go here and you'll be able to find it. All of the code we have up until now. Now when you go into Lua and then into Love2D, you'll have the Asteroids game folder, and that's what we are building. And we are at number 15, so you can get number 14's code if you have fallen behind, or if you just want to get a few things that we'll get to in a second. Once you finish this course, and you don't know what game to build next, I do have a few things I want you to try and do on your own, and also point a few out during the gameplay whilst I show you what we're implementing, what you could also add. So here is a lot of things called homework. And you don't have to do this, but if you do this, you will learn how to build a game on your own without my help, which is very useful because I won't always be there to hold your hand while we code a game together. Sometimes you'll have to do that on your own. And this is where it can start. There's a lot of things you can do. Create a settings page. Because if we look here, we have a settings button, but it doesn't do anything. So you can implement that settings page. That's what I want you to do. You can add more sound effects, which we'll be doing in this video. You can add a better design to the menu. Add mobile support. Add items to the game. So let's say you want to give your player better guns. So let's say after every third asteroid they destroy, maybe a random gun will spawn that they can, if they hit it, then instead of exploding, they will equip the gun, and then they can shoot better lasers than what they currently have. Which could help them, like once they get to like level 500, if they have a very powerful gun, it could be an easy game. You can add more enemies because currently it's very basic. But you could add, like in the original game, an UFO that will occasionally also jump in and maybe shoot the player or just try and hit him. And then you should also try and destroy that UFO. You can improve the performance because currently it's not really focused on performance. If you have a very powerful PC, you won't even notice it. But after this tutorial, if you have a low-end PC, you might notice frame drops going till 30 FPS, if not lower. And last but not least, or not yet, but you can also add a better pause screen. And then last but not least, you can add multiplayer support. This is something that can bring you very far in the future. You can go and get yourself a Lua module, the Love2D module, or just Lua module, and you can start trying to code your game that two people on two different computers can try and play the game together. It's going to be a very difficult thing to do, but if you get this right, you can make any game and you can make it multiplayer for more people to play together. And the multiplayer game is usually a bit more successful than the single player games because multiplayer games you can play with your friends. So here's a bunch of things you can do, and we'll go through a few extras in the video as well. Now in this video, we'll be adding background music and sound effects. I want you to go here to our GitHub page, go to number 15, which is the last one. Then you'll notice here inside of source, we now have a new folder called sounds. Go into sounds, and here you'll also find all of the sounds we will be using in the tutorial. And you can just open all of them. And then you'll notice there's a download button, and you can just download them all. So you click download, and did it start the download? Yes, there it goes, it downloads. And you just download all of them until you have all of the sounds. There you go. Once you have all of this, we can just move this back to a different screen. We can then open up our file manager, and here under source, we can create a new folder called sounds. And we can then go here to downloads, where our things should be. And we can just copy all of the sounds we just got. And we can just throw them in here into the sounds folder. And there you go. Now you might have to rename a few of them because the names are now incredibly long and tedious. So let's just go here. There we go. Oh, I didn't do anything. There we go, okay. And just rename all of them. Alright, now you'll notice we have two types of sounds here. First we have OGG and MP3. This is just to show you can use multiple sound types. But usually you'd find people using OGG and MP3. And a lot of people also use WAV or WAV. Now I just chose OGG because I think that's what I got when I downloaded these here. You can also play them if you want to. I would play them, but I don't think you'll actually hear it now that I think about it. Alright, so I quickly fired up a different screen recorder, so if the quality might be a little bit low, that is just because I'm using OBS instead of my simple screen recorder as usual. Now, we can actually hear how this sounds. So if we actually go here and just say open containing folder, we can hear how all of these sounds. So the background music. Yeah, then we have the explosion asteroid. So that's when an asteroid explodes. Then when the player explodes. And of course you could change these sounds to be something else. I just went online, did a quick Google search for free music or free sounds, and I just downloaded the first one I saw. So you could definitely change this if you want. That's how laser will sound. Then an option select, like selecting a button. Then the thruster. Then the thruster but louder. Yeah, I couldn't remember why I had both of these, but we'll try and find out right now. Alright. So now we have the sounds. Next up, we can go to components and create a new file called sfx for sound effects.lua. And like usual, this will go local. Love is equal to require love. And we have our function sfx, which will return a table, and you can just return sfx. Alright, so first we probably want to select the background music. So let's go up here and we say local BGM, local BGM is equal to love.audio.new source. And remember, if you're wondering about any of this, this is on the Love2D documentation. So just go to love2d.org, I think, and then you'll find a documentation which explains this as well. Then we should select the background music. Now we can say src, then sounds, and then bgm.mp3. So src, sounds, bgm.mp3. So we just selected it. And then we want to set the mode to stream. Stream is when you have long audio tracks like background music, for example, that's going to continuously play for a long time. So let's say it's 30 seconds or longer. You probably want to use a stream. Cool. Then you want to go BGM, go to the next line, BGM, set volume, because the volume will be very loud, but you could change this depending on how you like it. And I'm going to set mine to 0.1, which would be very soft. But the volume will be very loud, but if you want it louder, you could make it louder by just increasing this number. Then BGM, set looping to true. And this will make sure it loops continuously over and over. So once the background music ends, after it's like 30 seconds or whatnot of playing, it will start playing it again. Cool. You might think this is annoying, but a lot of games actually do this, where you just play the background music over and over and over again. And usually people don't find it too annoying unless the background music itself is an annoying tune. Cool. Now we want to link all of our effects, so all our sound effects. So you can go local, effects, and this will be a table just to make things easier. It doesn't have to be a table, but I'm going to make it one. I'm going to copy this line of code, just remove the local, change BGM to ship, explosion, and make that equal to everything here, but we're going to change this to this explosion player .ogg, and we're going to change from stream to static, because static is better for these shorter audio tracks, like that's 5 seconds long or 10 seconds long. If there's very short, then static would be better. We can then just add a comma here and then copy paste it 4 times. There we go. Then this can be asteroid instead of ship. And then of course we just change from explosion player to asteroid. Keep it static, whatnot. Then this we can change to the laser. And here I'm spelling it with an S because here I figured out you actually spell laser with an S and not a Z. So just in case you want to know. But if you want to stay consistent, because if you link your laser with a Z, you could change that to Z. And then here we say laser. Here we can call this select. And then option select. And then thruster. Which will of course be thruster but loud. So if you think the thruster is too loud, you could probably go for normal thruster. But this is just for making it a little bit louder because I think this normal thruster is probably a little soft. Cool. Now first, when we play an effect, we should have a true or false value to say if an effect has been played. So fx for effect and then played. We make that equal to false because by default nothing is being played. Then set fx played, and this will basically just set this fx here to true or false. You don't have to use a function for it, but I'm going to use a function for it because it's just a bit safer. We're gonna go function self and then has played, and then just self dot s or fx played equal to has played. Now we want to create a function to play the background music when we want it to. So we can just go here and say play BGM for background music. That's a function, takes in self, and we can check if not BGM is playing. So if the background music is not being played, then end. So this right here just checks if the background music is currently being played. So if it's going dee 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 in the background, then BGM play. So if it's not playing, we want to start playing the background music. Cool. Now we need 2 more functions. First one is to play the effects. So if we want to play a sound effect, and then the other one is to stop a sound effect from playing. So let's first do stop sound effect because that's the easiest one. You can say function takes in self and then the effect. Then if effects, and then we want to pass in the effect. So this right here will go to the effects and see if we pass in like a ship explosion string or asteroid explosion. And then it will try and select that one to see if it currently is playing. Which if it is playing, then you want to stop the effect from playing. So we can just copy this and then say stop. As simple as that, and that will stop the background music from playing. Next up is to actually play the effect. Now playing the effect is a bit more complex because we have so many effects. We can just say play fx is equal to a function that takes in self the effect we want to play, and in the mode we want to play it in, and I'll explain this in a second. Now we will have 3 different modes. We'll have single, and the single mode is when we only want this effect and no other effects to play. Then we have slow mode, and this will just play the effect as normal. And then we have the else, which will just stop this effect from playing if it's already playing, and then start playing it again. Alright, so let's implement that. So if mode is equal to single, and it might sound a little bit confusing right now, but you'll understand what I mean in a second. Then if not self.fx played, then so if the effect is not being played right now. Then self colon set fx played to true, so we want to set it to true. And then if not effect currently is playing, then we want to go effects at effect play, and this will play the effect for us. So basically this is in the sound effect that's only allowed to be played once. That's why it's single. Next up we want to do the slow mode. So else if mode is equal to slow, then if not effect, so the current effect is not being played, then effect, and then play. Now, usually you don't actually have to do it like I'm doing right here. It's just I like to have a little bit of variety in my effects. They shouldn't all just be generic. There should be like different versions of it. For example, single, where it's only allowed to be played once. Slow, where it's allowed to be played, but we first check if it's currently being played, then we can play it again. And then finally, last but not least, where we'll stop the effect and start playing it again. Okay, that can be any other command other than slow. So else and single, of course. Self stop fx, and it will stop the effect, just like here. And we can just say effect, and then effects at effect, and then play it. Cool. And that is the sound effects file. It could be much bigger, but I like to keep it a little bit simple for right now, because you might want to expand on this later and you don't want it to be too complex. So let's start by going to the main.lua file. And here in reset, we can just go sound effects is equal to sound effects to create a new sound effect object. And of course we should import it. You can either use dot or slash notation. As you can see, I use both of them here as an example. So sfx, and we can just go to components dot sfx. Now when we load the game, we want to start playing the background music. So we can just go sfx and then play BGM, and it will start playing the background music for us. Cool. And let's play our game and see what we get. And as you can see, we get background music playing for us now. Alright. So that is for the background music. Next up, let's go to the menu here and let's just pass in sound effects for all three of these. SFX, because we're going to add sound effects to all three of them. And we just change the player lives to 3. Player also has another player object being created here, so we can just pass in SFX here again. There we go. And we'll later on change that in the player itself. Now first let's go to menu, which should be here in states. And first we can take in the sound effect, so SFX. And then here where we go to run, when we check if the button is being hovered on. If it is being hovered, then you want to go SFX colon play, or play, and then FX for the sound effect. And you can say we want to play the select and single. Alright. So it should be able to run if it's not going to crash because of those nil values. As you can see, it kind of plays. However, we need to also add another line of code right here inside of the else statement. So if self.focused, so the one it's currently focused on, is the same as the name, then we can go sfx set fx played to false. Because if you could remember, if we go here to SFX and we go to single, then here it sets it to true, but here we check if it's already false. Now we are manually setting it to true or false depending on the context. So we don't want it to play multiple times over the same button. So we're saying single here, and we have to reset it to false here if it has already been played before we are allowed to play it again. You could remove this if you want to. It does help make everything just work fine. Now go, as you can see, you can now go over all of them and you can do it multiple times. Cool. And as for the menu state, next up, let's go to the game state. And all we need to do here is just where we create this asteroid, we can just also pass in SFX for sound effect. Because the asteroids will also have sound effects for once they explode. And before we go asteroids, we can go player, which should be inside of objects and player. And first we can take in sound effects. And then first, here with the shoot laser, I believe, because that's when we want to play a shoot laser sound effect, we can just go SFX, play, FX, and then just the laser. And since we're not passing anything in, if we go here to SFX, that means it will stop the effect if it's currently playing and then start replaying it. So let's run that and hope it works. As you can see, now if I were to spam the button, you'll notice it just keeps on playing. Because the sound effect is so short, you don't actually hear the sound effect getting cut in half, basically. So if you spam it, you're not going to hear that sound effect being cut in half, which it is currently actually doing. Next up, we can go back to player and just go to move player. And in here where we say if self.thrusting, so if we're currently thrusting the player forward, we want to go here and just say SFX, play FX, and we want to say specify the thruster, and then slow. And slow, of course, if we go here to slow, it will just check if the effect is not currently being played, then it will just start playing the effect. Alright. And we can do the same here at the bottom, but now we can just say, if we're not currently thrusting ourselves forward, SFX stop, FX thruster. Cool. Let's see if that works. Oh. That's weird. Let's try it again. So at 30, we're trying to index a nil value. So right here. Okay, so thruster seems to be a nil value. Also, it seems we haven't taken an SFX here in game, so you can just also take that. And let's see here. You know what? I spelt incorrectly. There we go. Now it should work. Okay. Alright, you'll notice every time we now thrust, it makes a nice sound, and it stops once we stop pressing the W key. Cool. Then last but not least, we can go to asteroids. We can go to the top, we can take in sound effects. Then we want to play an effect once we destroy the asteroid. So in the destroy function, once here, when we resize and whatnot, we can just pass in the sound effects as well, because we're creating new asteroids. And then at the end, before the remove, we can just say SFX, play FX, and then we can just say asteroid explosion. Then if we run it and we shoot an asteroid, we should hear and there we go. So now you hear that every time you shoot an asteroid. And just like that, we added sound to our game. And believe it or not, that actually took me a whole day to implement on my own. Just because we did it pretty fast doesn't necessarily mean it was very fast. Anyhow, and that is the end of the Love2D crash course. Thank you all for watching. It was a very fun experience doing this with all of you. Now, before we go, I might want to give you a little bit extra homework if you're up for the challenge. You might want to make this on the background to make it look cool. Have the asteroids be flying in the background. Wouldn't that be cool if you're here in the menu state and it does that? Alright, and if we go to new game, you might want asteroids to explode when they hit each other. Wouldn't that be cool as well? But then, of course, the player score doesn't necessarily have to increase. But it could be pretty neat if two asteroids were to hit each other and then explode into more asteroids. And yeah, that's about it. You can also try porting the game to Android, which I have not really tried, but it would be a pretty difficult challenge. And if you get it right, then you can make Android games for yourself and for your friends. Thank you all for watching. I hope you all enjoyed following along in this course. And I will see you all again in the next tutorial, whatever that may be.